Okay, it looks like we can go ahead and get started today. Thank you for joining us for the second day of our 2002 Alaska Sustainable Energy Conference virtual workshop, Nuclear Energy in Alaska, the Issues and the Opportunities, sponsored by the Alaska Center for Energy and Power. I'm Gwen Holdmann. I'm the director of the Alaska Center for Energy and Power, which is based at the University of Alaska Fairbanks. I'm actually coming to you from snowy Juneau today. And I'm going to be your MC for the event. Thanks for joining. As I shared yesterday, this is a series of 4 virtual workshops that are going to be held monthly as 2-day Zoom sessions, just like this one, free of charge, leading up to the Alaska Sustainable Energy Conference, which is happening in person May 24th through the 26th at the Denina Center in Anchorage. That's hosted by the governor. And so we're hoping that you can join us for some other topics if they're of interest. We sort of selected topics that we think that there's a lot of things happening either nationally, globally, or in Alaska. And it's an opportunity to kind of share and have like some really informed discussions on some really interesting energy topics that do impact Alaska's future energy mix. So yesterday, we addressed the first 2 questions in this particular small nuclear workshop, which is basically what we really did is organize it around sort of 4 themes like, does the technology exist? Is it safe? And then today we're going to really be talking about, is it economic and is it responsible, socially and economically responsible? And after those panels, I'm going to have all of the 4 moderators, including the 2 from yesterday, come back together. The moderators for this workshop are all Alaskans that have been working on or thinking about this topic and have largely helped organize this workshop. I especially want to give a call out again to George Rowe with the Arctic Energy Office and David Lockard with the Alaska Energy Authority. He'll actually be moderating this 4th panel. The idea of bringing them together to kind of talk a little bit about what they heard, lessons learned, and sort of next steps. And so I really hope that you'll be able to stick around for that sort of readout and reflection in that last panel. And I'd also like to remind everybody that there is a chance to stay engaged in this topic through the Alaska Nuclear Energy Working Group, which we host on a monthly basis. I'm not sure we're going to have a meeting in February, but in March, we're hoping to hear about the Alaskan Air Force project from the Air Force. And so that's probably our next working group meeting. Let's just see. So just a few housekeeping items. I'm never very good at these, but I have to remember to do them. So when you, if you guys could just drop your name and introduce yourself in the chat. I noticed we have some folks from other universities joining and from around the country. Yesterday, we had 94 participants that joined us for the workshop at various times. Some folks dropped in and out at various points. Most of those were from Alaska, but we had some folks from around the country and industry represented as well. If you're having any trouble with audio or viewing the presentation, chat to the event support folks. We have a really great event support team that is from Government Event Services. They've done a fantastic job. So if you have any questions, just go ahead and text them directly, and they should hopefully be able to help you. During the workshop, all attendees are going to be muted, and so you submit questions or comments by using the chat feature. We're going to wait and hold questions to the end of each of the panels, each of the sessions, because the speakers have to some extent worked together to make sure that we're getting information out there. And so your questions might be answered by the second speaker in a panel if they were not answered by the first speaker. And then we're going to ask the moderators sort of curate those questions and hopefully we can have a real dialogue. That's one of the things that I thought was really fantastic yesterday. We just had a really great discussion and some really excellent questions that were asked. And so I'm hoping that we can do the same thing today. No pressure, Christy and David. The recording for this workshop and the slides are going to be available on the Alaska Sustainable Energy Conference website at a later date, probably about a week out or so. So just check back for more information. We might send an email out to everybody that registered for this conference. And then just one quick last minute housekeeping. We have a slight change for the second panel today on Is It Responsible? Ron Johnson will be replaced by Rob Burnside, both representatives of the Nuclear Energy Tribal Working Group. So we'll have to, Rob's really pinch hitting here for us today at the last minute, so we appreciate him being willing to do that. So quickly, before we dive into today's panel, I wanted to just quickly recap what we talked about yesterday. As I mentioned, we had 94 people that attended, mostly from Alaska. I think that we just had this really fantastic dialogue. I'd like to maybe actually, Sarah, if you could just go ahead and go to that, go ahead and go to is the word cloud the next slide? Is that right? Yes, awesome. Okay. This is kind of the word cloud that we did yesterday that we sort of created. And I thought it was pretty cool that I felt like was reflective of a lot of the topics that we're talking about during this workshop. You can see a couple of the biggest words here: safe, clean. So those are a lot of the topics that we sort of talked about yesterday to some extent. But expensive and reliable are big words here, the next couple of bigger words. And, I see these as like a lot of the questions that I hear from Alaskans. Is this actually a real technology that's going to become available at some future date, or is this sort of just theoretical, like in 10 years, this might be something that's coming down the horizon, and it's always sort of being pushed back a little bit like that. There's a lot of questions about safety. I think that we talked a lot about those yesterday. I felt like the presenters there did a really fantastic job of really kind of setting some context for us there. In particular, in that panel, we had Mohammed Shams from the Nuclear Regulatory Commission and Bruce McDowell from the Department of Energy that I thought did a really fantastic job, following up on Alice Campaniti with nuclear energy, and Christine King from the Gateway for Accelerated Innovation in Nuclear, or GAIN. So anyhow, I think that for this word cloud, the fact that there is always these other questions about like the environmental effects and also the economics of these systems. So even if they do exist, are they economic? And so I'm pretty excited to hear a little bit from folks and their perspectives on that today. There's been some really good work done on that as well. I want to just do one more fun poll to start us off today. And so if we could go ahead and do that. It's an activity. We did this yesterday. So for those of you that were with us, you go to this pollev.com/TOTTAK216 to answer the poll questions. And today it is, which generation technology has the highest fatality rate per megawatt hour of generation? So we came up with these questions before the workshop started. So for those of you that were here yesterday, this is a little bit of a test of how well you were paying attention, because I think Bruce answered this question yesterday. So yeah, and it looks like people are largely getting that one right. It is coal. I think that people have, I'm interested in that people have sort of this perception about nuclear energy being, dangerous. And I really thought that, and of course it can be, I thought that Bruce really, one of my takeaways from yesterday was, Bruce really kind of talking about some of these facts about nuclear energy safety, and really talking about like how in the 60 years of the nuclear energy industry in like 38 countries, that there's really only been 3 major accidents, and only one of those actually resulted in any deaths from either nuclear reactor workers or the public. And that in general, nuclear actually has a really good safety track record. But of course, there are a lot of concerns and legitimate concerns about, especially in remote or sensitive environments, and what that could mean. And so that's one of the reasons why I'm excited for the last panel today that David's going to be moderating. Okay, we have 100% on coal. I don't know how people, they must have changed their answer. Can you do that? So, but anyway, okay. And I do, though, want to also just kind of highlight, and I'm hoping that David in the last panel can talk about this a little bit. I do think sometimes when we're looking at new technologies, it is important to compare it to the status quo. And we use a lot of diesel fuel in rural Alaska, and the amount of environmental contamination that's been caused by small and larger diesel spills is I think really an untold or underappreciated story. We feel more comfortable with fuel oil because it's something that we use in our everyday lives, but there's actually a lot of environmental impacts associated with those sort of status quo technologies that I don't think that we always appreciate. And so one of the studies that we're trying to do at the university is really trying to understand what the impacts of those sort of status quo technologies are in order to be able to compare them to something else or something new or different. So that's part of the work that we're doing. So with that being said, I would like to go ahead and introduce the third panel. Is it economic? And I want to remind everybody that you can submit Q&A questions in the chat box. There's not a separate Q&A feature. So just go ahead and drop those in, and Christy will pay attention to those. So I am really excited to welcome Associate Vice Chancellor and Director of the Alaska Business Enterprise Institute from the University of Alaska Anchorage, Christy Bell. Christy is somebody that I have had the pleasure of working with for a very long time, and they've actually been University of Alaska Anchorage and University of Alaska Fairbanks have been working together for over a decade on looking at this small modular reactor space, both through the Business Enterprise Institute. They've done some really great work that was funded through the Department of Energy, looking at doing a market analysis and really talking to stakeholder groups in Alaska, and also with the Institute for Social and Economic Research, which has done a lot of the economic valuation of these kinds of systems in the Alaska context with us in the past. And so, Christy, it's a real pleasure. Thank you for joining us. We really appreciate you being here today and the partnership that we've had over the last several years working in this space. So thank you.
Thank you, Gwen and team. And I, too, am so excited to be part of this dialogue. So thank you for the invite. And I truly applaud all the important work that you and your team have been taking on. So good morning, all. I'm Christy Bell, and as Gwen said, I lead the University of Alaska Anchorage Business Enterprise Institute, or the BEI. The BEI is a suite of business and economic development programs intentionally placed under one umbrella to link and align these assets to better engage the university in the work of diversifying Alaska's economy. So I bring a couple lenses to this topic. First, as a trained economic development practitioner, that experience has taught me that we have to do some deep work today to be thinking about and strategically planning for our futures that often occur in 10 to 20 year forward buckets. So I really, again, applaud the work that Gwen is initiating here, because we're starting to plan for our energy transition and our economic future as it occurs 10 to 20 years out, resetting every day. And then the other lens I bring is as a member of the Idaho National Laboratory, or INL, Emerging Energy Market Analysis, or EMA team. That experience has opened my eyes to nuclear as a tool for consideration. And as we prepare here in Alaska for an energy transition, that experience has been invaluable. So again, I'm excited and looking forward to our work here today. The team and I at the BEI work in all industry sectors, and much of our work is focused on determining the feasibility or economics of various developments. In many cases, the cost of energy is the factor that determines whether something's feasible for pursuit. And in most cases, we don't have energy solutions. And so oftentimes we are working with our clients and having to determine that something's not feasible. As such, I'm eager to roll up my sleeves just like you to learn more. And I believe Alaska is already on the cusp of an energy transition. So that planning today that we can dig in and determine our future is so important. So it's my honor to now introduce to you to who I believe are two national thought leaders shaping the conversation around nuclear and whether it's economic and how we incorporate nuclear into our national toolbox. Let me introduce you to our first panelist, Mark Nichols. He's the Senior Director of New Reactors for Nuclear Energy Institute, or the NEI. Mark Nichols joined the Nuclear Energy Institute, or NEI, in 2011 and is the Senior Director of New Reactors. In this role, he leads industry's efforts to improve the policy and business environment for the building of new reactors. Mark has previously worked for Duke Energy, Toshiba America Nuclear Energy, and TransNuclear in the areas of used nuclear fuel management, operations, and new plant projects. Mark holds degrees in nuclear engineering from Purdue University and the University of California, Berkeley, and an MBA from the University of North Carolina. I'm going to go ahead and introduce John Parsons as well. Dr. John Parsons, I've had the privilege of working with through the Emma team of INL. He's the Associate Director, Center for Energy and Environmental Policy Research, or CEPR, at the Massachusetts Institute of Technology, MIT. Dr. Parsons is a senior lecturer at the Sloan School of Management. His research focuses on the valuation and financing of investments in energy markets, as well as the problem of risk in energy and environmental markets, and the role of trading operations in energy companies. He is currently an associate director at MIT's Center for Energy and Environmental Policy Research. He was a co-director of the recent MIT study on the future of nuclear energy in a carbon-constrained world. Dr. Parsons serves as an associate member of the US CFTC's Energy and Environment Markets Advisory Committee and has been a visiting scholar at the US Federal Energy Regulatory Commission. He holds a BA in economics from Princeton University and a PhD in economics from Northwestern University. So I look forward to both of you walking us through the economics. What sort of ownership models might be expected? What kind of modeling has been done, how you think we might be able to move into this new space. And I think, Mark, you're going to kick us off.
I think so. Thank you, Christy, for that great introduction. Welcome, everybody, and thank you for the opportunity to present to you today. I'm going to bring up my slides on screen here real quick. And what I'd like to talk about are some cost and economic modeling that the Nuclear Energy Institute has done for microreactors. Our report is about 2 years old. In the cost estimation, we actually worked with the developers of microreactor designs to get the cost inputs on what the expected range of costs would be. And then we also worked with our contacts in Alaska to better understand what is the current cost structure there with the current energy supply, especially diesel generators, to be able to do some cost comparisons to see what are the economic potential for microreactors there. So I want to go through a lot of details in that report. I'm going to start with this graph, which is a high-level summary of all the information. And this is usually the slide we end the conversation with in most presentations. So everything beyond this is actually going to be more detail and more looking under the hood of how we came up with these numbers so that you can really get a better understanding, because top level numbers like these are important. But if you don't understand the nuances and context of it, the application is a little bit limited. And so this graph actually is a little bit complicated in the information it shows. I'll talk first about those green horizontal bars. Each one of them are labeled. And these are the current costs that we estimated for different market segments. And so we have remote Arctic communities there in green at the top. They are some of the most expensive current cost of energy. Below that, some remote defense installations. Below that, actually some overlap. The blue and overlaps purple. Island communities and remote mining. We had a special section there, Alaska Rail Belt, which is in the orange, that's just above the U.S. grid. So while the Alaska Rail Belt is certainly the least expensive in our estimation in Alaska, still slightly above the U.S. grid. So that gives comparisons. As we looked at this, and I'll just take remote Arctic communities as one of the examples, we know that most of the time the incumbent generation, or what's currently there, are diesel generators. And so with a diesel generator, there are a lot of costs associated with the fuel, especially the transportation of the fuel to that site. Now, there are going to be costs that are wrapped up in capital and annual O&M and that sort of thing. What we did is a conservative approach is we said, well, those diesel generators, if you were going to replace them with something else, a microreactor or even a different technology, really those capital costs, they're already sunk, they're amortized. You're not really saving those costs because you're now abandoning that asset, so to speak. And then the other is, well, okay, even if you didn't do that, you may actually want to keep the diesel generator around just as a good extra backup in case something happens. It's there, it could work, and so you may still have some of those operating and maintenance costs. So we said we're not going to calculate those. We're only going to base it on the cost of diesel fuel, the fuel itself, plus the transportation to different areas. That's why you actually see quite a big range in many of these areas because of the transportation cost. Transportation to hard to reach Arctic areas where you can only come in once a year and you have to bring the entire year's supply of diesel fuel. You have much higher cost versus something that is easily accessible by transport and you can bring it in just about any time. And so that accounts for a large amount of those ranges. And then on top of that, we have the three lines that go across. We have the red line at the top, the purple line in the middle, the blue line on the bottom. They all on the left-hand side start a little bit high. They come down quickly, and then they almost plateau as you get out. The scale or the dimension on the x-axis there is the number of microreactors deployed. And so what we know is with anything, the more you build something, the more you can reduce the cost. You get certain lessons and learnings in producing that you apply to the next one that helps make it more efficient, and you apply that to the next one. It's actually, we used a very well-proven estimation tool for this. And it's basically that there is a certain amount of learning that occurs every time you double the production. And this is true for nuclear. It's true for other energy sources. It's true in things like semiconductor industry. So it's sort of a universally proved phenomenon. And so within that, the variable then is, well, what is the learning or the cost reduction you get every doubling? And we apply here, well, we could say it's 10%. That's what most people are estimating, but it could be higher. We've had experience in the nuclear industry, not so much in the US, but especially the Koreans, that suggests, well, maybe it's higher than that. And then we said, well, but we don't want to be too aggressive. We haven't actually produced microreactors yet. We don't know what that might be. So let's have another case that's more conservative, that's on the 5% side. Now, within those learning rates, we applied those to the different curves there. I said before, the red is the high cost, purple is the middle cost, and blue is the low cost. We actually had a range of cost inputs. Particularly the capital cost. We have a pretty good estimate on what we think the capital cost is, but we haven't built them, so there's some uncertainty around it. There's also some uncertainty in terms of, well, how big is the reactor? Do you have a special purpose factory for these? What are the design considerations that go into it? So there's a natural range anyway based on design. And so that accounts for a lot of that variation. But then there's also uncertainty in ranges for what's the operating and maintenance cost, what's the fuel cost. If you have to replace the fuel, how frequently do you have to do that, and how much will it cost? Some of these reactors will operate 10 years without refueling. Some will operate 20 years without refueling. Some may replace the entire reactor when they refuel. Some may not. So there's some variability in that. And so what it shows here, the purple line is actually our best estimate for what we think microreactors are going to cost. And if you look at that, it suggests that, well, the very first microreactor we produce, we think already it'll be less expensive to produce power than what's already there. And that, as I mentioned, that's only considering diesel fuel cost. So it has the opportunity to immediately, even the first reactor, dramatically reduce the cost of electricity. And then if we're able to optimize on the design, we could get those costs even lower. If we sort of overestimated what we're able to do with microreactors, even at the high end of the cost, it's still going to be less expensive than many areas. Not as many, but still some. And then over time, with those lessons learned, we expect that these will be more cost effective than the current generation in a larger and larger number of situations. So we think this has a lot of potential, certainly worth investigating and pursuing some demonstration projects. On the next slide, I want to talk a little bit about some sensitivity analyses we looked at. So the slide I just showed was based on an assumption that the microreactor will be operating all the time. Because nuclear power is high capital cost, very low O&M and fuel cost, the economics work best when you're producing power at 100% all the time. And it also is dependent, because high capital costs depend on financing. It also depends on what is your business type in terms of financing cost. And so here we have a couple of different investor and ownership models. If the microreactor is owned by, say, an investor who is not backed by the communities or the government, then they pay a little bit higher rate for interest on loans. And that's what you see on the left side. Now, there are loan guarantees, especially from the federal government, that helps to reduce that financing interest rate. It gets it closer to what a government rate would be. And that has a dramatic decrease, has a dramatic effect to decrease the cost. So those loan guarantees are especially important for investor-owned. On the other side are publicly owned companies, and these might be municipal electric utilities. They might be federally backed utilities, and they get a much lower interest rate for borrowing. And you do see that the loan guarantee has a benefit. The benefit is not as large, but there still are some benefits. But the biggest conclusion here is, I'll just compare the investor-owned loan guarantee with the publicly owned, and let's just say not with a loan guarantee. You can see the costs are pretty similar. And so what this suggests is we actually have a lot of opportunities for different business models here. We could have a developer come in who would be more like an investor-owned at a higher interest rate, get a loan guarantee, and actually provide the power on a power purchase agreement basis to the local utility or whoever the off-taker is. And the cost would be about similar to that public utility having owned it and financed it itself. And so the cost of electricity is pretty similar. You get some advantages. The developer that's doing that PPA, they take more of the risk. They have to manage the fuel when it's finished. They have a lot more responsibilities. So in either one, there's attractiveness to both types of business models. Whether the utility is looking for convenience, just to be an off-taker and not an owner, or whether the utility is looking for, we'll be an owner. We're not too concerned because the microreactors are simple, and we see potential to make some savings there. On this next slide is looking at different capacity factors. If you were to operate the reactor full power all the time, let's just call that a conservative 95% capacity factor, adjusting for some factors like refueling and those sorts of things. And that's where you get your best cost. Well, what we see is if you're only operating at, let's say, half the time, that's 45 to 55%, your costs are almost double. And that makes sense because your variable costs are almost zero. And so you're producing electricity at half the amount. You have to cover all those, I'd say, capital costs over half the amount of energy. So your price is almost double. And so what it really suggests is, well, we need to be operating these reactors at least 85% of the time. You can see that 85 to 95% capacity factor isn't a huge impact, but it is still an impact. And so the question is within this, and as you look at the operational models, is that, well, if my power demand fluctuates over the day, greatly, or even fluctuates seasonally, then I need to take that into account. And if I'm looking at using microreactors primarily to serve all of my needs, then how is that going to impact the economics? Or does it make sense to integrate these things with storage or renewables or other things that could help with those peak times? And so those are some of the factors to consider. The other thing to think about is, well, maybe I need more than just electricity. Maybe I need heat. And so is there some synergy that you get from producing electricity and heat? Because, well, when I need more electricity, I can scale back on the heat. When I need less electricity, I can increase on the heat. And so the reactor itself is producing power 100% of the time, or 100% power all of the time. But the products that are coming out of it are able to flex and match the demand that's being created. You could even throw in there hydrogen. And I saw there's going to be a webinar coming up on how to use hydrogen and use synthetic fuels and that sort of thing. And so if you could use the microreactor to also generate your synthetic fuels, that becomes another energy product that you can optimize the output. This will be my last slide. I did want to touch briefly on what is the cost of producing heat versus other sources, because all of that previous work I just mentioned is specifically geared toward electricity. And so what we see here, this is we're going to use this slide uses hydrogen as a proxy for heat. Now, the market may go to the direction that everything's converted to electricity is converted to hydrogen, and then hydrogen is used for heat processes, or we may have direct use of heat. But it's simpler to use hydrogen as a proxy in terms of economics comparisons. And so this report that we reference here is from Lucid Catalyst recently. They looked at, well, what is the cost of hydrogen that's generated by many different sources? They looked at solar, wind, and then clean heat. And clean heat certainly includes nuclear, it can include some others as well. They have geothermal. But the point here is that, one, the hydrogen has to be clean, so it has to be generated from zero carbon sources. And then two, the cost is very important when it comes to hydrogen. And what you see is that as you look at LWR, PWR, those are nuclear reactors. HTGR is a nuclear reactor as well. Now, these aren't microreactors, so the specific costs may change a little bit with microreactors. But what it finds is that nuclear powered or hydrogen coming from nuclear power not only is clean, but it's one of the cheapest sources of hydrogen as well. And so that's really a key insight into this chart. Now, why is that? Part of the reason is that we find that heat-assisted hydrolysis or heat-assisted processes for generating hydrogen is much more efficient than using electricity alone. So that's why my earlier comments on using a microreactor for heat and electricity might be a very interesting option. With that, I think we're going to hold questions until after both speakers. Is that right?
Yes, Mark, sorry, in my little transition there, I removed myself from Zoom. So we'll have some questions. There's some great questions in the chat that you might be thinking about. And it's my honor to have John Parsons now step in. As a reminder, John is the Associate Director of the Center for Energy and Environmental Policy Research, CEPR, at the Massachusetts Institute of Technology, MIT. And I've had the privilege of working with John through the Idaho National Laboratory Emerging Energy Market Analysis Group, and I have just tremendous respect for him. So I hope you enjoy his presentation here.
Thanks very much, Christy. And it was a pleasure to be here, and I appreciate this entire event that you and the other colleagues have put on. Thanks very much for including me. So yes, I'm going to use a few minutes to give you a quick piece of info about some of the research we did about microreactors in Alaska. I'll try to keep it short so that we can get to the questions, because I've already noticed, yes, there are quite a number of really good and interesting questions in the chat. So this is work I've done with one of our postdocs, Rory McDonald. And I wanted to bring out that this is work which, as Christy has said, I've been a part of a team that the Idaho National Laboratory has put together, the Emerging Energy Markets Analysis Project, with colleagues at the University of Alaska, Michigan, Wyoming, and us at MIT. I'm going to be presenting this work on economics, but it's a piece of this larger project, and it's supposed to be one tool in the toolkit to craft a holistic approach to economic development and energy's role in that, and the needs of a community. So I'm just, well, like we're having one panel here out of 4. In that spirit, I'll present the results from this piece of work. So what we did is we tried to look at microreactors and how they might be used by a variety of different communities in Alaska, similar to what Mark was doing, but done slightly differently. I'm going to reduce it here to 2 types of communities. These are not specific communities, but just general types of communities. So on the one hand, I'm going to focus on rail belt communities, which in general are going to be larger. They're a part of an interconnected grid, not a very dense interconnected grid, but nevertheless a part of a grid that has a number of different generators on it and serves a number of different communities. I'm going to model one which has a peak electric load of about 480 megawatts of electricity, peak heat load of 1,590 megawatts thermal demand, primarily for heating in the winter, of course. And those loads are going to be shaped, and that's going to matter for our work. We're going to be looking at the load throughout the year, the hourly load going up and down. So we're going to be trying to find where a microreactor can fit in a system that's serving the entire load. This rail belt community will have access to natural gas, the one we're looking at, or we can examine what will happen if it does or doesn't. And I'm going to talk a little bit about maybe you have access to district heating facilities so that the reactor might be able to be used for heat. We're going to be looking at a portfolio of generation that can serve this community. So there can be a variety of different generators, some diesel fueled, perhaps natural gas fueled. Renewables can be a part of that system. And so we're going to be looking at the renewable resources available in this community. And they're diverse depending upon which communities you have. So for example, there's much less wind in Fairbanks. On the other hand, if you're down at Anchorage and you can exploit some of the offshore or nearshore wind, it's a much better resource. Similarly, the insulation is different where in different places. So we're going to pay attention to that location-specific resources. So I'm in the end today going to be presenting some results for renewable resources like they are around Fairbanks. The other community is going to be a small off-grid mine. So it will primarily be, the load will be primarily driven by the mine. In particular, the heat load might be primarily driven by that. The communities will be relatively small in the neighborhood of that off-grid mine. And there will be no access to natural gas in this location, but it does have access to renewable resources. And so then what we're going to do, as I hinted at earlier, is we try to figure out a portfolio of generation that can serve this load. We're going to be working with the transmission network as it is, so I'm not going to be talking about additional transmission, but different combinations of generators are going to cost different amounts. And in some of the modeling, we'll just be trying to serve the electricity load. In others of the modeling, we'll also be looking at heat generation and trying to figure out, we're going to serve the electricity load, but maybe we can also serve some of the heat load. In particular, you can either serve the heat load if you've got district heating capacity, which there is some, for example, in the neighborhood in Fairbanks, and you can use some of the waste heat from the reactor to serve that district heating load. Or you could use direct heat from the reactor, in which case you would be sacrificing some of the electricity production from the reactor. And so I'm just going to boil things down to 3 key results that came out of our research. So if I try to build that optimal system, the 3 factors that turn out to be the most important are, does your system have access to natural gas? If it does have access to natural gas, that's going to be, no surprise, a very cheap source of electricity generation and the source of competition for a microreactor. It's going to make it much harder for the microreactor to be a component of this portfolio, to be competitive economically in the portfolio. A second factor is going to be the size of the heat load. That's going to work in the different direction. That is, if you have access to a district heating network, and if the heat load is very significant, then the microreactor may be able to play a very economically useful place in the system as a part of your portfolio. And the third key factor is whether or not you have a need to reduce pollution. And there are different types of pollution. So, I mean, Fairbanks has an air quality problem. And so you might want to reduce the criteria pollutants in order to improve the local air quality around Fairbanks. But CO2, reducing greenhouse gas emissions, reducing carbon emissions is another pollution criteria. So in our paper, we focus just on the CO2, just to ask, if you want to reduce CO2 and you're thinking about ways to construct a electricity portfolio of generators that will meet some standard, what role does a microreactor have in that system? And so the bottom line out of those 3 key factors is, if you don't have a need to reduce emissions, natural gas is going to be the fuel in the rail belt community. And in order for a microreactor to be economically useful in that community, it's going to have to be extremely low cost, basically head-to-head competition with low-cost natural gas generators. If there is a need to reduce emissions, it turns out that the microreactor is very economical in a rail belt community, primarily because the ability to serve the heat load provides an enormous amount of economic value on top of the cost of producing electricity. So that access to a district heating network sort of reverses some of the economics that Mark was talking about a few minutes ago, that in fact, in a rail belt community, it is the reactor can be very economically valuable because of the ability to provide district heating. And you can combine these things, that reducing emissions where the value of reducing emissions where you have the ability to provide heat load turns out to be a really good economic case for a microreactor. So that's the results of our research. I know that in the materials for this conference, the conference organizers have provided you the link. I repeated the link here. I just wanted to lay that foundation for this conversation. I've already seen the chat has a good number of many interesting questions besides this, so I look forward to participating with everybody in the Q&A.
Thank you, John. And I think Mark's going to be joining us in just a second. And it's our opportunity now to have a bit of a conversation with the data that you provided. But first, I want to thank you both. So often, I think Alaska gets a little misunderstood at times. And it's clear that both of you have put in a tremendous amount of time to understanding some of the nuances related to Alaska. And I know that you've both put in a lot of time to help educate us here. So thank you both. So let's start off and start diving into some of these questions. I'm really curious as it relates to some of these needs and where to start. Clearly, energy will be transforming in the coming years and decades, and how best to position Alaska for this opportunity. And you've gone over the economics associated with, the applications, and have addressed some of the nuances of both power and heat, and how that they could be of support. I'm curious how business and industry and can engage better in part of this dialogue. There's some questions over in the chat regarding specific to the North Slope. Where are we at? It's kind of a
Well, so our work is intended to try to be helpful to that. We didn't, as Christy will know, in a lot of our conversations about trying to develop some useful tools for communities in Alaska, we were not one-on-one partnered with a particular community. So we were trying to build a tool that could be available and used for different communities that might come forward. So we did this, we made up a remote mine community, but that to show how we would do the modeling there. We could certainly look at a North Slope producer and try to implement the model there based on whatever electricity load, heat load, and facilities are at that location, and try to determine whether or not, or under what circumstances, a microreactor might be economically a useful contribution to that location.
Yeah, I think that is aligns with my thoughts. Just to add on a little bit in thinking through this. So you're asking specifically in terms of, how do we engage in businesses on or investors on practical or specific use cases for this. And I think that's the next step in this. We have spoken with some companies that have mining operations or are planning mining operations in Alaska. And the feedback I've gotten from them is that, well, this is really attractive. This would meet our energy needs. Energy security is really important to us. The economics look good. There's different places in which some of I'll just say mining specific uses might be, well, they already have power. It's, not something they want to switch over at this time. Or if it's a new mining operation, well, it takes a lot of years to plan. And so microreactors are not yet there where they can sort of bank on it as part of their project. So I think we need to make more inroads there. I'd also say, as we look beyond just the mining industry use of it, and we look at other even manufacturing or other uses within all of Alaska, is that I think there's three primary constituents in the conversation. Certainly, we just talked about the industry the industries or the customers, the businesses that would use it. Communities is certainly one of the most important as well. And so is this something that the community is comfortable with? And that's the next panel. So I'm really excited for that. And then the third one is, well, what about government policies? Government policies can either support or hinder the adoption of any technology. And so within Alaska, are the policies conducive to moving everything forward, or are they an inhibitor?
Thank you both. And I kind of jumped in there partly from the mindset of an economic development practitioner, from the standpoint of, if we don't have a real market driving this, I'm worried that some of the technology might not get out there as efficiently and as quickly as it could otherwise. And so how might we learn from the history of renewable energy systems and how they've been able to enter the marketplace, what costs and benefits drive some of the, individual businesses or communities making a decision to make a transition. In many cases, at least the work that we've done, the least cost always wins out. And it seems to me that there's opportunity, and you kind of started to step into that area, Mark, that government policy and or government investment might start influencing some of this.
Mm-hmm. Yeah, I think, John, you probably have more perspective on renewables than I do, but I think that was one of the biggest drivers for renewable was the government support behind it. So with any first technology, it's always more expensive than the lowest cost alternative. Microreactors we think might be different here in Alaska, but if it's more expensive as a first of a kind, how do you get into the market if the market is looking for the lowest cost solution? That's where government support and policies come in, and those support and policies for renewables help to make the business case and help to incentivize customers or I'd say businesses from purchasing and utilizing renewables. We need the same thing for nuclear. We have a lot of support at the federal level, but support at the state level is really important as well.
Brett, I would just add that there's, on the one hand, there's support to reduce costs, but I think anybody who's going to be thinking about, for example, a microreactor, you're always afraid of being the one stepping out first and then being left behind later, left alone later. That is, we're all talking about it now. People will encourage you to make investment, but what happens 3 years down the line if there are difficulties or something? Are those people still there? I'm talking about state officials, technology people, and so on. So you really need a demonstration of commitment from others to coordinate that this is something you can do for a whole number of reasons. And I think the government plays a role both at the federal and the state level in providing the assurance in a number of different ways that will make the businesses be comfortable with playing their role as well.
Great. And then as it relates to renewables, and this may be, again, just too much from an economic development practitioner, but I'm curious, is there a window of opportunity that can serve to disrupt this, disrupt the technology in such that it can advance at a faster pace. It just seems like there's different ways that we've seen renewables enter the marketplace. I kind of reflect on our current oil situation and how the Alaska economy's been put in such a flux, and whether something like that. I'm curious your thoughts there.
Yeah, I think there is a lot of opportunity for I'd say disruption or for microreactors to be quicker in disruption. And particularly because of the nature of the technology, how they're when you look at nuclear, I should say, when you look at nuclear energy, it's typically a lot longer and slower to deploy a nuclear reactor than it is for another energy technology. And that's where the disruption of microreactors comes in. Because they're so much smaller and so much more simple, we have an opportunity to deploy them much more quickly. And one example of where that time advantage could come from is in the regulatory space. And so the NRC has been looking at how to optimize and streamline the siting of microreactors. I don't recall if Moshams mentioned all of this yesterday or not, but they have an idea in place that they're working on, which would take siting from many years to maybe even 1 year or less. And so the regulatory process could be much, much shorter for these. And just by their very nature, as we get into more factory, and especially if we get to a big enough order size that we can get purpose-built factories for these, you could be turning them out very quickly and deploying them very quickly. And so speed to market, I think, would be a very big disruptive force within microreactors.
Anything additional, John?
No, I think that's really true. I think the nuclear industry has appreciated that the renewable industry has done an excellent job of driving down costs. And key way for driving down those costs is having a product that is manufactured, and the manufacturing facilities have just improved the process tremendously as volume has happened. And so turning around and saying, oh, geez, we need to be able to do that in the nuclear industry also. And the microreactors are a good example of that. And I'm participating with teams of people trying to really focus the mindset in design on being able to exploit the benefits of factory production and learning from doing over a large volume of numbers. And it's hopeful, so we'll see.
And that's been another topic that I've been really curious about. How do you get there? So I agree completely with what you've said. And simultaneously, I'm curious, how do we get the supply chain in place? How do we start building those manufacturing facilities? In at least from the work that I'm involved in, I don't see those manufacturing facilities really starting to emerge and produce at a scale that's economical without the market driving that. So how do we, have you thought through what, it's a chicken and egg question a bit.
It's definitely a chicken and an egg problem. So there's no getting around that. However, you have to have the design that could conceivably work that way before you can actually then worry about the chicken and egg problem. So an enormous amount of progress has happened in the last couple of decades in a number of technology fields that make it feasible to downscale the size of an individual reactor and to make that smaller reactor economic. We have to exploit all of those technological improvements in related fields and produce the package, which, if mass produced, could be low cost. Then we get the chicken and egg problem. But I think it's really important to appreciate that there have been all these advances that make it possible for designers to reimagine a nuclear reactor and to give us this thing we're talking about called microreactors.
Yeah, no, I absolutely right. I would add that I know the microreactor developers are working with supply chain partners to identify who would be able to produce different components, and so that's being developed. The suppliers that are out there and can be found would be sufficient to build the first reactors. So the question really focuses on how do we get to, I'll say, special purpose factories that can really dramatically reduce the cost. And that to me is all about an order book. So somebody's not going to build a brand new factory only for microreactor production unless they have the confidence that their investment is a wise risk. And it's a wise risk if you have an order book. That doesn't necessarily mean we have to have 150 firm order commitments with deposits on it. But we do have to have some sense of customers that are wanting this and the demand that's there. And we've talked with the DOE Department of Loan Program Office, and they want to help in this regard. And they've said the same thing. If you can develop an order book, and that could just be indications of a large number of customers that say, yeah, if you hit that price target, we would buy one. Then the loan program office can bring in tools to help start up those factories.
And I'm not gonna capture them all, but the chat has a lot of questions going right now, and the piece that kind of is resonating with me at least is there's some examples of coal projects that there was significant federal investment on the front end. Do you think the federal government is going to have to be that significant buyer on the front end to create a market? That seems like one avenue, and perhaps we see more MRE investments on DoD sites, or the other alternative is you make the costs less significant, whether it's through loans or actually helping on some of the front end development of these manufacturing sites. What direction is it going to be? Both?
Yeah. So I think, maybe a bit of both. I think based on our work in our on the economics that show that even the first microreactor is going to be cheaper than what's already operating. And in discussions with a lot of the developers that are out there, I think that a private market only could develop and deploy microreactors. So I would not say that federal government as a buyer or as a cost share supporter is the only way to deploy these. I think private investment only will deploy microreactors. But where it comes in is that if the government is a customer, they can order a lot of these. If they're cost sharing in some of the designs, they help to offset the risk of the first customers. So if the government is involved, we can deploy these much more quickly in larger numbers. But I think even if the government doesn't get involved, we'll still see microreactors happen.
Excellent. And Gwen's kind of pulling the string on this in the chat a bit. So can you talk a little bit about how business ownership models might, you started discussing it right there, but the Eielson project here in Alaska is designed to be set up as a public-private type entity. Is this the expectation of other projects?
From what I've heard, most of the interest is in power purchase agreement models, where whoever is going to be using the power is contracting for that power and will pay you for the power you provide. And so the developer, might have a partner who's an owner, they would own it, they would take a lot of the risk. And that's why I say that private only models could work like this, because microreactor developers, some, maybe not all, but some microreactor developers are willing to take the risk. And the reason they're willing to take a risk in the financial risk of owning it and supplying power through a power purchase agreement is because of the small size. the costs are really low. So we didn't talk about an absolute cost of a microreactor, but let's just say it's in the $100 million range. Well, that's something that a developer could say, well, yeah, I can afford that risk. Investors can afford the potential of losing $100 million because the deal doesn't work out, where you can't do that on a larger reactor that's a couple $1 billion. So yeah, there's a lot of interest in that power purchase agreement. I don't know if that'll be the only business model, if that may shift over time, but we are seeing that as a great interest.
Yeah, I'd like to add, so I agree with Mark that the power purchase agreement helps to take care of the financial risk. But there's another advantage with these microreactors that will open them up to being used by a lot of different businesses that, buy their own power or have a power plant associated with their factory or are interested in having power or heat provided, but would never have thought about nuclear, not only because of the size, but do they want to be an operator of a nuclear plant? And existing nuclear plants have to be regularly refueled. And when they're regularly refueled, that means sort of opening up the reactor and handling dangerous materials. But with a microreactor, basically, first of all, you don't open it up and handle it. When it's time to refuel it after 5 years, for example, you could lift the entire crate out, take it away, put a new microreactor in, and you're back in business. The fuel handling happens somewhere else. So you could have a owner operator of these reactors vending to customers the service of providing energy to them without the customer having to become themselves a nuclear operator. So in our university neighborhood, we have a lot of biotech firms in the neighborhood, some of whom produce their own heat for their experiments and for their manufacturing. But they don't own, they own the facility, but they contract out to somebody to run the electric generator and the heat production facility, because that's not really their business. And you can similarly do the same thing with these microreactors. You could have a specialist nuclear operator who handles and takes care of your operating and maintenance and so on. And I think that opens up a much larger universe for nuclear to provide heat and electricity to industry and to specialized communities. For example, a hospital that needs secure power and things of that sort.
I'm curious on the kind of that train of thought and thinking about, the North Slope or even some of the mines in rural remote areas. Is there a potential to, as an operator or business, to purchase and then move it between locations in a safe way? And I know our topic isn't safe, but that seems like that starts to get into a more economical.
Yeah, it's from a technological and safety aspect, it's absolutely possible to be able to operate a microreactor in one location for a certain period of time, turn it off, move it to a new location, turn it on and operate it there. There are some and in fact, the Department of Defense has a demonstration program. They call it a mobile reactor. So they're going to demonstrate mobility features specifically for DoD needs. But their idea is that technology could be commercially available too. So absolutely, it's possible. You also run into some, I'll just say, logistical challenges, because each place you would want to operate it, you'll have to get NRC approval for that site ahead of time, and it may take some time. I said that ideally we could get down to a year. So these wouldn't be rapid movements. You wouldn't say, well, I'm operating it here and I decided next week I want it some other location. You wouldn't be able to do that. But if you were to say, okay, I'm going to operate this mine for 5 more years and then it's done. And, a microreactor operates 20 years. Well, I don't want a 20-year asset that's only going to operate 5 years. But if it has this mobility feature that says, well, I can operate it there for 5 years, and I know far enough in the future then I'm going to want to move it over to this other mine that I've got under development, and that's when I would need the power over there. Well, you would have plenty of time to work through those logistical considerations and be able to move it from one location to another.
Excellent.
Yeah. I don't know if you're going to get to this question or not. I saw Gwen had it in here. It's about a coal plant. And her comment was there's sunk costs with coal plants and sometimes loans that haven't yet been paid on that coal plant. And I'd extend that might even be true for diesel generators that we're talking about in remote areas. And Gwen's question specifically was, do we envision that there may be loan forgiveness at the federal level? And I'd say I don't believe there's any right now, but I would not put it out of the question. And I say that because, at least with the current administration, as they've come in and they've set more aggressive decarbonization policies and even federal procurement requirements, they've at the same time recognized that that's going to have a negative impact on communities that host coal plants. And I would say they recognize that for remote communities that have diesel generators that might have to be shut down to meet these goals. And what they've set up is I think it's a working group or a task force, but they've set up within the administration a think group to figure out, well, how can we support these communities? Because the closing of a coal plant, it can be devastating to the communities. How do we preserve these communities and make sure that they're not negatively impacted as we make this transition to clean energy? So while those ideas may not be there, if there is something that would be helpful in transitioning from fossil fuels to cleaner energy sources, I think that at the federal level, there'd be a lot of reception to understanding what those needs are.
Is there anything that keeps either one of you up at night or that you noodle on a lot as it relates to bringing this technology to market in an efficient and effective way?
Well, the biggest challenge, just so we're all aware of it, but the biggest challenge to microreactors is the fuel. And so we have the ability to fabricate the fuel, but a lot of the fuel that is going to be used is up to 20% enrichment. It's still low enriched, it's still safe, but it's higher than the current 5% enrichment. And so the availability of that fuel supply, especially as we deploy more and more advanced reactors, is really critical. We are working with the federal government to overcome those challenges, but it's something that we all need to be aware of, because if we're not aware of it, we may forget about it and not solve the challenge. But we are moving toward making sure that fuel is available. Yeah.
And is there anything else in the supply chain? We kind of brushed through that one question earlier. I'm curious if there's anything in the supply chain for these manufacturers, particularly as supply chain is such an issue right now.
No, I would say that, as Alaska is looking at the potential for microreactors, and if this becomes something that all of Alaska says we want microreactors, and in fact, we may want a lot of them, then it would make sense that some of the supply chain ends up in Alaska, just from a logistical transportation type of thing. So I think the question maybe is more for Alaska to look at is, well, what of our current manufacturing capacity could be utilized or upgraded to be able to help be part of this supply chain for microreactors, would have economic benefits and job benefits along with it and that sort of thing. And with that supply chain, I'd say Alaskan supply chain for microreactors conversation, I'd introduce another new idea. And it's built off of, you may not know, but the University of Illinois Urbana-Champaign is looking at deploying a microreactor on their campus, and they're going to produce power and heat for the university because they have high needs. They supply their own. But at the same time, they're looking at it as an opportunity to have a reactor to help train people on and learn about how microreactors operate. Well, if Alaska is interested in microreactors and a lot of them, then, would it make sense for one of your universities to have a microreactor? You get the benefit of heat and power, but it's also a place where you can train your workers on the operations of these facilities to actually go out into the field one day and be the workers at the plants.
Excellent idea. John, anything additional on that one?
No, nothing to add.
Yep. So Ben Cross is asking if we can talk a little bit about the need to standardize microreactors.
Well, that's absolutely key. The whole benefit of factory manufacture is that it's got to be something that's standardized, or you won't really be able to do factory manufacturing. And so that's the challenge in the design, is to make it so that it can be mass produced, so to speak. So
I would wholeheartedly agree with that. The standardization is key, especially for microreactors. And but I would also say that standardization doesn't mean that we only have one microreactor design. I think the market potential is big enough where we could have more than one microreactor design. Is it 2, 3, 4 or more? I don't know. But if you look at it, certainly we're looking right now, Alaska only, and that market is a particular size. I don't think anybody's actually sized the market potential for this, but it's a particular size. But we have to remember there's also Canada. Canada wants microreactors for their Arctic and their mining operations. And so the synergy between those two markets, just because they're so similar, is huge. And then you start to look at, well, islands would really like these. I know Puerto Rico is looking at this. The U.S. Virgin Islands is talking about this. There's been talk about this for Guam. And then you look at it, well, beyond that, even internationally, microreactors could make a lot of sense in remote villages in Africa, for example. And so as you look at the worldwide market, bring that scope beyond out, open the aperture beyond Alaska. And I think the market is big enough to support many different designs. But within each design, standardization is critical.
So I'm going to whiplash us back to that manufacturing kind of comment. And it's been something that I've been considering in particular in some of what you just said, Mark, as it relates to Alaska's global position and what our opportunities might be here. We have a very infantile, emerging manufacturing sector. And our greatest challenge has often been the supply chain in really engaging in any greater manufacturing. So I'm curious what, and George was asking this, and it was something that I was kind of noodling on as you were, asking your earlier question. Are there any other industry sectors that we might be thinking about to create some capacities now to really, build that supply chain, to build our manufacturing capacity, or other areas, ways that we can enter into this space? Because I see it as an opportunity, but the chasm seems large.
It absolutely does seem like a large chasm. And I don't know all the particulars in terms of the supply chain, but the one I would focus on is advanced manufacturing. So based on what you said in terms of Alaska is a little bit behind the curve on manufacturing and trying to catch up, advanced manufacturing offers a unique opportunity to leapfrog, because if you look at, well, we're just trying to do traditional manufacturing, you're trying to catch up. Everybody else is further along capacity and capabilities. But when you look at advanced manufacturing, emerging technology, everybody's at the same place on the plane. You're not at a disadvantage in advanced manufacturing. So if you could get started with understanding, well, what is the manufacturing that these microreactors need? How can we as Alaska leapfrog other states and other countries and advance our advanced manufacturing so that you're the eminent leader within this, at least for microreactor needs? Well, now you have a strategic advantage over other places.
Giving you a second, John. You look like you're deep in thought. I've seen that look before.
I'm trying to think about what's different about microreactors that enable something for Alaska that wasn't possible before? If it creates new flexibilities for energy that Alaska has not had before, then it enables some kinds of manufacturing that hasn't been maybe so easy to provide in the past. So one of the good things about the microreactors is you can have, so to speak, remote energy production easier, and that energy production is useful for industry. So that's where I would be exploring. I don't have an answer, but I would be trying to ask, what does this make possible that was not possible in Alaska because the situation was different?
It's a good question. Something for us to tackle a bit more. All right. We have another one. I think we touched on this some, but how might we improve our manufacturing capabilities here in the U.S. when we're seeing other folks like South Korea starting to enter this manufacturing space in heavily?
Yeah, it requires an investment in U.S. manufacturing, and we've been having that conversation at the federal level. I know our federal government wants more manufacturing in the United States. There is some difference between the microreactors and even the SMRs. I see NuScale was specifically mentioned. So even SMRs, they are now smaller than traditional reactors. They can be manufactured in factories, but microreactors are even smaller than that. And so the capabilities you need in terms of the equipment you might need for traditional manufacturing processes like forgings and rollings and that sort of thing are a lot smaller. So our capabilities may be able to accommodate those. And so that brings up opportunities. The other is that even, microreactors eliminate even more of the safety-related, the NRC calls safety-related components, and that brings special nuclear quality requirements and other things that most manufacturers currently don't comply with and sometimes aren't interested in complying with them. So they now become unavailable as supply chain providers. And so that opens up the world of possibilities. So I would say the world of possibilities of manufacturing is much greater in the US for microreactors than other designs. And then I will just come back to this advanced manufacturing. So, and I'll just give one example. So I was at Oak Ridge, this was, I think, 2 years ago now, and they had manufactured, it was a Navy thing. I think it was a small, I don't know, a small thing, but it was cylindrical and it was about the size of a microreactor. And they said that traditional manufacturing, it'd take, a year or two to manufacture that. With advanced manufacturing, they were able to manufacture it in a matter of weeks to months. And so that greatly reduced the time, that greatly reduces the cost. As advanced manufacturing, this was a 3D printing technique, becomes more advanced, you might actually get better performance out of the final product that way. So that's sort of the thought. Nobody has these advanced manufacturing 3D printing machines that are capable of manufacturing microreactors. But say Alaska or anywhere else in the United States, if they were the first to develop these machines and deploy these machines, then they might be a natural choice as a supply chain.
I'm curious, and I'm starting to reflect back on your comment about maybe a university could pick this up, and it seems like there's a role both for the proof of concept, being the user of this technology, as well as engaging in some of the emerging manufacturing components. So incorporating that. I'm curious how much of the workforce development piece has to be developed in order to step into that, or whether you've seen any examples where those linkages exist pretty quickly.
So the workforce development I think is still we're working to clarify it a little bit more. The ultimate goal for a microreactor is to have very few people that need to operate it. That the design itself is so simple and so safe that the operator requirements are pretty minimal. In fact, it would operate itself. It would go up in power, down in power, turn itself on and off all by itself. Some of these things will take time to develop and improve, but nonetheless, we're looking at a small workforce. Let's even just say 5 people, or it could be smaller than that. And the types of skills that are going to be needed are not the same skills that we need at even a small modular reactor, where you'll have to know much more technical detail in terms of chemistry or radiation protection, or even how a nuclear plant operates. So we're looking at microreactors that could utilize skills, some out of high school, some out of a 2-year community college even. And so, yeah, the workforce development becomes a much smaller ladder to climb.
So we're starting to narrow into our closing here. I'm curious, what didn't I ask you that you really wish I'd asked, or what other closing comment do you have for us?
That's a tough one. I hope people appreciate it. I mean, we started off really asking a very narrow question, which was, I mean, both Mark and I, how can a microreactor, what's the economics of which a microreactor can produce some electrons cheaper than some other generation? But now we've been talking about how you can use microreactors differently, what opportunities they open up for different industries. And that's where I think some really exciting answers come from. And so continuing in that direction is where I think the discussion belongs.
Yeah, I would agree with that. And I think continuing the discussion is the most important part. I think we're at the very beginning still of this conversation. I know this conversation's been going on for several years, but we're now getting into the more interesting part, where we're starting to mix the conversation of, well, who's going to use these, and then how are you going to manufacture these, and what are the policies behind these, and what do the communities think? Are we addressing all of their concerns? And to the next one, which is, let's look beyond Alaska. Who are our partners, like Canada and other countries, and how can we as Alaska be a leader in this space and benefit from that, not just today, but long term?
Well, thank you both. I can see Gwen getting ready to hook me off the stage, and I so appreciate, again, all the time and effort that you've given to Alaska and your expertise in this space. I learn tremendous every time from you.
Well,
thank you for having me.
Yeah, I'd like to second that. That was such a fun conversation, Mark, John, Christy. Thank you so much. I totally agree with what you're saying there, Mark. And this is a little bit of, we don't have final answers here, but really like thinking about these valuations and continuing to kind of tweak these numbers as we have like sort of real use cases that we're starting to look at. That's something we'd love to continue to work with both of you on in the future. But we're going to go ahead and take a 15-minute break. There'll be a countdown timer and come back right at 10:15 sharp for our fourth panel, which is going to be moderated by David Lackford with the Alaska Energy Authority. So we'll see you shortly. All right. I'd like to welcome everybody back from our break. Before I introduce our fourth panel, I want to remind everybody that we have this wrap-up panel immediately following it. So I hope you'll all stick around when we bring the moderators back together to really kind of digest a little bit what we've learned and talk about next steps and moving forward. So Ben Cross was just dropping into the chat that asking the right questions is more important than having the right answers. And I totally agree with that. I think what I've been really impressed with was sort of the breadth and depth of the types of questions that we've had here. And, Ben also kind of mentions that he's great to see Alaska asking questions versus blindly following what people are trying to sell. And I think that that's very true of Alaskans. That's pretty in keeping with our spirit. We have a lot of good questions, and we recognize the unique unique aspects of our environment and our state, but we also are really interested in exploring new options and new technologies that might work up here. And I've always been really proud of our utility industry and our communities for being really open-minded and thinking about those kinds of opportunities. So as a reminder, during the session, questions can be submitted via the Q&A. I think we've all gotten very good at that. This is one of the most active Q&A chats that I've seen during a workshop. And we'll hold the questions probably to the end. And we've got two speakers again. And with that being said, I'm going to welcome our next moderator, whose title is an infrastructure engineer of the Alaska Energy Authority, David Lockard. But David, I do not believe that that's really an accurate representation of your role with AEA. I think that I'm going to challenge you. I think that you are the person that has the most titles, either currently or in past iterations of your work at AEA, of anybody that I know. And I was actually kind of writing some of them down and thinking to myself, the easier question might be what you haven't done at some point in time at AEA, because at different times you've been the hydrokinetic program manager, the solar program manager, certainly the nuclear program manager. That's why I've been working with you in this space for a long time. You've worked in bulk fuel. You're currently very involved with the rail belt. I decided the only thing I couldn't think about was wind, but wind is something you've dabbled in quite a bit too. So anyway, you have a pretty well-rounded perspective, especially in both rural and rail belt energy issues in the state, and somebody that I've really appreciated your perspective for a long time. I know that you have spent a lot of time in many, many communities around the state and have a really great perspective of what's happening. And so I really appreciate you taking the time to moderate this panel, because I can't think of anybody that's sort of in a better position to sort of think through some of these issues. And I know we've been having these exact sort of conversations over the last more than a decade. So thank you, David. I'll turn it over to you. Yeah.
Thank you, Gwen. This feels kind of like old home week to me. You said a decade, but I think it's more like 20 years since I met you at Chena Hot Springs. And it was great to see Christy, and she's a hard act to follow. I met her when our kids were in elementary school together, and those kids are in college or graduating now. So yeah, it's really nice to see familiar faces. I put this photo on the screen, not so much to show that Alaska is a little different from some other parts of the country, but because I wanted to share a thought that I had related to advanced nuclear reactors. And that is, it's not obvious initially at first blush that going smaller is going to make nuclear reactors a more valuable technology, or at least it wasn't to me. I'm a mechanical engineer, background in construction, largely in powerhouses. But I want to challenge all of us, and myself particularly, to consider how the fat bike you see in the picture there also is not obviously an interesting improvement on bicycles. The tires are so big that it's heavier and slower than if it had small tires on it. And when I first saw fat bikes, I thought, well, that's just a flash in the pan. It's not going to work out. Well, it turns out they're enormously successful. In fact, you see more fat bikes on the trails around Anchorage than you do skiers. And they're really fun, and it's a successful technology. So I guess I'm trying to keep my mind open to the idea that advanced reactors might be a revolutionary technology instead of an evolutionary technology, and that it's good to think about or ways that we might open our minds to the possibilities out there. So the session title is it environmentally and socially responsible? And I really appreciate Gwen's and the other comments about questions, because I think this session, at least for me, needs to focus on what questions should Alaskans be asking regarding advanced nuclear reactors. It's really important for us to be responsible for our own benefit, for the benefit of our friends and families in Alaska. So With that, I'd like to introduce Susie Baker, our first speaker. Ms. Suzanne Baker is a senior advisor at to the Assistant Secretary of the Office of Nuclear Energy at the Department of Energy, where her work is focused on equity, justice, and community engagement. She previously served as the creative director for the Fastest Path to Zero initiative at the University of Michigan. Ms. Baker has also worked at think tanks Third Way and Good Energy Collective, as well as the Idaho National Laboratory. She is a graduate of Appalachian State University. I'll turn it over to you, Susie. Thank you.
Thanks, David. All right, I'm going to try to share my screen here. Am I up? I think I'm up. Okay. So David, thanks again for the intro. I'm thrilled to be here today to talk a little bit about how the Department of Energy is working to improve our social responsibility and the way that we partner with communities and do business overall. In my role, I'm a senior advisor to the Assistant Secretary. I've only been in the job for about 6 weeks. This is actually my first presentation since joining the office, so bear with me. I've got like a lot of notes and I'm gonna try to cover a lot of ground. So my focus is on equity, justice, and community engagement. And I just wanna say up front that I am definitely not an expert on Alaska or Alaskan issues. And so in addition to sharing some information about my office, I'm also really here to listen and to learn and to try to understand how we might be better partners in supporting Alaskans in reaching their clean energy goals. Okay, so I'm gonna jump right in. Or let's see if I can move my slides. Okay, there we go. So I think this was touched upon in the last session and potentially other sessions yesterday as well. But the Biden-Harris administration has made some really, really ambitious climate commitments. We're trying to decarbonize the entire economy by 2050. So this is no small feat. Communities and states across the country are trying to figure out how to do this. And it is going to be a both social, political, and technological marvel to pull it off. And it is, pushing conversations like the ones that we're having today about how to achieve it. And nuclear power has been recognized by the administration as a critical tool in reaching this goal, primarily because of its low pollution, low carbon profile. So nuclear is an official climate technology. It's on the table for how we reach these goals. As y'all are, I'm sure, very aware, Alaskans have some of the highest energy prices. You are on the front lines of climate change. And Alaska Native communities have some of the worst incidences of pollution-induced asthma rates in the country. So we know that these are issues that are impacting Alaska and Alaskans now. And as a potential partner, I really hope that we can, as an office, provide the information, technical assistance, and even financial assistance that you are going to need to tackle these major challenges. So a bit more on the Office of Nuclear Energy. Our mission is to advance nuclear science and technology to meet the U.S. energy, environmental, and economic needs. Our top priorities are to keep existing plants open as sort of a foundation of our low carbon economy, to build advanced reactors and modernize the fuel cycle, which a lot of this conversation about microreactors is sort of rooted in that piece of our mission, and to manage our spent nuclear fuel, which I will touch on more in just a moment. So there are a couple of opportunities right now that I want folks to be aware of to engage with our office. The first is for tribal members and leaders. And actually my fellow panelist, Rob Burnside, I believe is a network member. And so hopefully he'll touch on this, the good, the bad, and the ugly, and his experiences working with our office and some of the opportunities and challenges there. But this is basically a working group that has, it was created in 2014 And it's been endorsed by the secretary, and it's a direct line for tribes to work with the Office of Nuclear Energy. Oops, I'm going the wrong way. There we go. Here's a list of members. This list sometimes shrinks or expands based on different projects or things going on. So tribes might join for a while to work out or work on a specific issue, and once it's resolved, they may take a break, but these are the current members. The next thing that I want to touch on is consent-based siting. So obviously, to make nuclear energy truly sustainable, we have to manage the back end of the fuel cycle. Management of the nation's spent nuclear fuel and high-level radioactive waste is the department's responsibility. This includes finding sites to store and dispose of spent nuclear fuel. And the way to do that, we believe, is using a consent-based approach. So essentially, not forcing anybody to take this material, but finding communities who are willing to work with us to find solutions and receive the benefits and not just the risk of this type of work. So by its nature, a consent-based process must be flexible, adaptive, and responsive to community concerns. And by working through the consent-based siting process collaboratively, we hope to build trust and beneficial working relationships between DOE and potential host communities. Potential outcomes from this process could include a negotiated consent agreement defined by the community in collaboration with DOE, or determination that after exploring the option, a community just simply isn't interested, and both of those we consider successful outcomes. We understand it's a daunting challenge, but we also understand the gravity of our responsibility to get this right and to dispose of these materials. So I want to alert you all to a request for information that is open now. We are not looking for communities to volunteer to take this material yet. We are actually asking for input into the process. So this is like, how do we even begin to design a process to manage this material? We know that we have gotten it wrong in the past, and we're looking to do better. So I welcome you all, based on your experiences or questions, to input into this process now, and to participate in this process going forward if you're interested. Okay, so in addition to those two immediate opportunities for engagement, there are a lot of new opportunities in the works that are aimed at fundamentally restructuring the way that we do business. So I decided to join this office to help with this because I believe in it so strongly. We have a mandate from the Biden-Harris administration to incorporate equity and justice in a cross-cutting way into everything that we do going forward. This is expressed in two primary executive orders. The first is the Justice 40 Initiative, which mandates that 40% of the overall benefits of our climate spending and clean energy go to disadvantaged communities. So the federal government obviously has been inadvertently a part of creating inequities in our society. And this is an attempt to correct for that bias that we've had traditionally. So if you are like, okay, cool, but what is environmental justice? This is a quick definition that we use inside of the department, and it is the fair treatment and meaningful involvement of all people, regardless of race, color, national origin, or income, with respect to the development, implementation, and enforcement of environmental laws, regulations, and policies. So many communities have not been adequately protected from all types of federal and industrial, but federally regulated activities in the past, and we are trying to do better going forward. Just from an operational perspective, you're like, okay, so how do you do that? And that is something that we're working on actively right now. So some of the big questions that we're working through are, how do we define disadvantaged communities? How do we define these investments? Like what counts and what is covered in our spending? And then how do we measure and track those benefits? So just to dig into some of these definitions. So in our interim guidance, a community is defined in two different ways. It can be a group of individuals in geographic proximity to one another, or a geographically dispersed set of individuals with shared experiences or common conditions. And defining disadvantage is also obviously quite challenging. But this is a list of some of the criteria that we are considering in making these judgments. I'm not going to read it to you because it's quite long. And the next slide goes into a bit more detail. So you can see there are sort of 4 major buckets that we are taking into consideration. Energy burden. So how much of your overall income are you spending on energy, which I imagine for many Alaskans is quite high. Fossil dependence, again, this is very resonant, I think, for many Alaskan communities who are dependent on fossil fuels. Vulnerable populations, and environmental and climate hazards. So we think all of these things are really critical as we try to push more climate funding to disadvantaged communities and making sure that they have the things that they need to sort of go through the energy transition. So the big policy priorities that we're trying to achieve by doing this are to decrease that energy burden, decrease that exposure to environmental pollutants, to work towards parity and access to clean energy technology, which I think is really listening to the conversation here today, to obviously bring down the cost of these technologies so more people can have access, to help small businesses, minority-owned businesses have a piece of this pie, to improve the pipeline and workforce development and job training, and to increase energy resilience and energy democracy, which I'm really quite impressed with this forum today and sort of as an active energy democracy and real public deliberation about the future of energy in Alaska. And the reason that we're doing this, the big outcomes that we really want to get to are wealth creation, workforce development, these reduced burdens, and long-term investments for communities. We also want to be transparent. So we already have a beta dashboard up that you can go and you can see and visualize and get spreadsheets to show you exactly where money is going, exactly what we're spending it on. And this technology, I think, will continue to improve as we learn. The second order that I would like to flag for this group, which is not as far along, it's sort of a few steps behind the Justice 40 work, but it is an additional executive order called Advancing Racial Equity and Support for Underserved Communities through the Federal Government. At this point, we are assessing potential barriers in enrollment and in access to benefits and services, agency procurement and contracting opportunities. We're looking at policies, regulations, and guidance that might be needed to move this forward. And we're also looking at what kind of resources we're going to need to support communities in having access to these opportunities. Here's our definition of equity: the consistent and systemic, fair, just, and impartial treatment of all individuals, including individuals who belong to underserved communities that have been denied such treatment, such as Black, Latino, and Indigenous and Native American persons, Asian Americans and Pacific Islanders, and other persons of color, members of religious minorities, lesbian, gay, bisexual, transgender, and queer persons, persons with disabilities, persons who live in rural areas, and persons who are otherwise adversely affected by persistent poverty or inequality. So a lot of different folks that we're thinking about with this order. And what that means for us and the federal government is a recognition that giving everybody the exact same thing or just providing access doesn't actually mean that you're achieving equity. And different groups, different communities are going to need different things to make up for some of these historical deficits. And soon we will have a publicly available equity action plan. And the big priorities that you should expect to see are just major changes in the way that the department does data collection, improvements in our procurement process so that small businesses and other groups that maybe couldn't manage getting through the DOE system will have an easier time working with us. And we're trying to be better partners, essentially. Improved access to financial assistance, improved stakeholder engagement, and improved access to the actual technologies that we work on. So that's it for me. Thank you so much for the opportunity to be here with you today. This is my email address. please reach out to me directly if we don't cover the things that you are thinking about or want to talk about here today. And I will hand it back to David.
Thank you, Susie. That was very helpful. I appreciate your presentation. Our next speaker, we particularly appreciate because Rob agreed to join us and contribute to this discussion on short notice. So I appreciate that very much, Rob. Rob Burnside is the fire chief for the Confederated Tribes of the Umatilla Indian Reservation, where he previously has served as vice chairman of the Tribal Board of Trustees. He's been an active lifetime community volunteer, currently serving on the boards of the Roland Schimmel Memorial Wrestling Foundation, the Happy Canyon Foundation, where he's vice president, the Pendleton Roundup Board, and the Washington Cutting Horse Association. Chief Burnside's certifications include Incident Command Type 2, Hazmat Specialist, Fire Inspector 2, Wildland and Structural Firefighter 2, and EMT Intermediate. Welcome, Rob.
Das may we. Good morning. Like you said, it's kind of a short notice thing. My mouth engaged much faster than my brain did. So with that, we'll just kind of get to it. I had a conversation this morning, and our reservation is in Northeast Oregon, and we're about 75 miles as the crow flies to the Richland area, which is northwest of us. And we're right on the I-84 interstate corridor. And we have the Union Pacific Railroad running through the reservation. And our reservation's 177,000 square acres. And we have no word. I did some research. A couple of the other folks from NetWig mentioned this, that we don't have a word for radiation in our language. So when Hanford first come along, the old timers were trying to understand what radiation was and how it affects things. And the thing they come up with was it's angry. And when radiation touches something, like I gave the example of somebody uses a wrench up at the Richland site to fix something, and that wrench is now contaminated with radiation. You can't see it, you can't feel it, it's just there. So the angriness was transferred to that wrench. Now it's no good. So they have to pack it up, send it to the whip site for disposal. So that's kind of how the old timers explained it. And so the tribes have been trying to make sure our culture and our natural resources are all taken care of. And so I've got a little excerpt that the tribe sent to the Hanford site regarding the small modular reactors. And I'm just going to read a little bit of it and go from there. So the potential impacts of the project are enormous and visible over a much larger area. In 1855, predecessors to the CTOI, ancestors with the Cayuse, Umatilla, and Walla Walla tribes and bands of Indians negotiated and signed our treaty with the United States. The treaty was a contract between sovereigns and is the supreme law of the land under Article 6 of the United States Constitution. And this treaty, the CTUIR, ceded millions of acres of land to the federal government, and in exchange received assurances that various pre-existing tribal rights would be protected and our interests would be respected in perpetuity. A paramount objective of the treaty negotiations was protecting and maintaining our tribal culture, traditions and way of lives, and first foods, water, fish, big game, roots, berries, and other plants, and critically access to them, and the habitat and ecosystem that support and sustain them, then, now, and forever. This is a duty that the United States undertook in the form of the trust responsibility to honor the obligations of the treaties. This objective, protecting, maintaining, and perpetuating our culture, remains paramount to the CTUIR. We have worked for decades with the U.S. Department of Energy and ensures laws enacted, enforce, protect not just our rights under the Treaty of 1855, but protect the individual sites and resources left by our ancestors for our descendants. So what that says is, we're wanting to maintain not just our treaty rights, but our foods and our way of life. The natural resources on the Hanford site, we used to go over before the Hanford site was created, and that would be an area for the tribes to gather with other tribes for root digging, medicine gathering, fishing, and trading. So when the Hanford site was created, of course, that took that portion of our treaty area or ceded area away, not just ours, but the Nez Perce and Yakima Indian nations. And so we were asked to write this letter or respond to that the question about the small nuclear reactors as a form of consent-based sightings. The one thing that we appreciate now, it's taken a while, but Indian tribes have been thought of more often as far as participants and recognized as stakeholders. And the native Alaskans should be afforded the same opportunity. So I don't know how things are working up there in Alaska. I know that the NETWIG, the Nuclear Energy Tribal Working Group, has been talking about expanding our core group, and we have participants from the Northeast, the Midwest, of course, out here in the West, and I don't believe we have anybody from the Alaska villages participating. So that's something that we would like to reach out to and find some participants from the Alaska area. Excuse me here. Got to check what little notes I have. One of the questions was, how do we develop an appropriate stakeholders education process? Well, first of all, you need to start talking to folks as far as what you're trying to do, what it is, and how it's going to affect and some of the ramifications, like the fuel storage, the transportation of the waste, where it's going to be stored, the storage of the nuclear waste, the transportation, like Alaska, I don't know how the rail system is, so I would imagine it would go by barge down to Washington and then maybe transferred to the rail. That's just something that needs to be explored. There's a lot of citizens groups that need to be involved and should be involved, not with just I got to back up here. The tribes, well, the Alaskan natives that participate in the nuclear reactors and small nuclear reactors and stuff, or that are near them, how are they going to be affected, and how are they going to be made to where they can respond or feel comfortable with the small nuclear reactors? And that all comes through education. So I think educating the folks and answering questions and interacting with them now instead of down the road when things are about ready to happen. I know it takes time, years, a lot of times that we talk about things, for instance, the nuclear waste, where are we going to put it? And so now is better than later as far as getting folks to participate with the education and consent-based sightings. I guess I was going to go over the net wig thing, but Suzanne already took care of that, so I'm not going to bore you with that anymore. So I guess we'll just go back to Dave and see if there's any questions.
Thank you very much, Rob. That was a great presentation, and you reminded me that there is actually a very important history of nuclear energy in Alaska that anybody interested in this topic should be aware of, particularly Alaskans. Gwen included, I think, most or all of it in her the reports that she wrote for and updated previously or recently. But the one thing I wanted to mention is that in 1958, Edward Teller, who was the father of the hydrogen bomb, developed a plan to detonate 6 nuclear bombs off the Alaskan coast to create a harbor. This was between Kivalina and Point Hope. That project was called Project Chariot, and it was stopped by local leaders, native leaders, and Alaskans. And I don't think anybody would ever say it was a bad idea to stop it. That was a very important part of the history here. And there's a book about it called The Firecracker Boys that I would encourage anybody interested in this topic to look up. So thank you for your presentation, Rob, and for yours, Susie. I will open this up to questions. I'd like to kind of revisit the topic. Is it environmentally and socially responsible? I took a nuclear engineering class in 1979, so kind of the middle of the last century. So I have no qualifications in that area at all, but I don't think you need to in order to ask good questions. And Rob mentioned one of them, what are you going to do with the waste? There's nuclear waste stored long-term in temporary storage at nuclear powerhouses all over the U.S. It's not an ideal solution. I don't think anybody would claim that it is. And I don't know of any alternative to that for sites in Alaska. So I guess I'll ask the first question, and I open this up to the group. Anybody who wants to respond to it, where would nuclear waste and spent fuel be stored at Alaska nuclear sites?
So, David, I can give you at least a partial answer to that. Any spent fuel created by reactors in Alaska would be subject to the same rules as all nuclear waste, and would potentially, need to be moved to an interim or geologic repository, which of course we don't have yet. I think one significant difference in this conversation between sort of the situation with conventional light water reactors and the large casks of spent fuel that are sort of sitting on site waiting for these facilities to become available is that we are talking about some pretty different technologies. So I think a lot of the focus of the conversation today has been on microreactors and potentially even SMRs, which are a little bit bigger, but still much, much smaller than conventional light water reactors. And so I know that some companies have sort of developed strategies to remove the fuel, have the industry partner remove the fuel, or have different sort of business models so that the waste is not on site. And I would say as consumers, you're in a really good negotiating position if you were to bring a technology in to say, these are our clear lines about what we're willing to take and not take. That said, it still has to go somewhere and it still has to be dealt with. And that is a larger set of problems that we are actively working on. But, obviously it's an incomplete process at this point.
Thank you, Susie. I see a question from Rory O'Neill at the University of Alaska. He's asking, is preparing an approved storage site in itself a decade-sized regulatory, financial, and socioeconomic endeavor? Does Alaska need this first?
I can't answer that question for Alaska, and I think it's a valid question.
Great. You know what? We're trying to identify good questions, and there's another one. So thank you for that, Rory. Another one that I had was, I really appreciated the economic discussion this morning, and I want to go back and review the information that was provided, but I'm not clear to what extent the economics or the cost of the nuclear power plants includes the cost of decommissioning and removing whatever needs to be removed. For example, there was a nuclear power plant at Fort Greely in Alaska that operated between about 1962 and 72. And it's in the process of being decommissioned, and additional nuclear radioactive waste is being removed at this time. So maybe that's a question for one of the speakers from the earlier session today. Does the cost that you're looking at include the cost of decommissioning the plant?
So I'm going to, again, give you possibly a partial answer. So for commercial reactors, that should be included. I think that the Fort Greely reactor was an Army reactor, so it has slightly different rules, and that may be why some of the decommissioning process wasn't accounted for. And I don't know the specifics of the situation, so I'm not going to comment further. But I do believe that the decommissioning, the whole life cycle cost of the reactor and even the spent fuel management should be incorporated into modern business models for these reactors.
Thank you, Susie. And I see a response from Mark Nichols in the comments that in his analysis, the cost of managing used fuel and decommissioning the reactor was included in the cost. And actually, maybe Mark, thank you for responding. And I have a follow-up question for you. Can you characterize what percentage of the cost is for security at the sites that you looked at in Alaska? Oh, he can't unmute. So maybe you could just respond in the chat, Mark? Or if he could be unmuted by Sarah, that would be great.
Okay, I'm unmuted now. Thank you. So we don't have a specific breakdown on the cost for security, and if we did, we probably couldn't share those numbers just because they could be sensitive from a security standpoint. But with these, I will say that what's different between microreactors than what we're currently familiar with reactors, they're developing what's called security by design. So the features themselves are going to be able to protect against any threats so that the plant will always be safe no matter what threat comes toward it. And so that'll help to reduce the security costs.
Thank you, Mark. And Lou chimed in the chat that Fort Greely is different from the technologies that we're discussing here. And that's absolutely true. Although I think some aspects of the analysis, such as talking about what we do with the waste, are probably relevant. And there's also a comment from John Hansen saying that Oklo does not plan to store used fuel at reactor sites, but rather to recycle the fuel. And they're very interested in engaging with stakeholders on that topic. One of the things that's come up, I think both yesterday and Rob mentioned it today, is related to traditional foods. And Alaskans are different from many other people around the country in terms of how much of our food we gather locally. I mean, even I, living in the biggest city, I have an annual ritual of catching salmon, and we eat it all year round. So I know from my experience on the Forum on the Environment that there is very deep concern among Alaska natives in Western Alaska about possible contamination of their food supplies from the Fukushima disaster. Everything I've heard is that that's not a major concern, but I do think this is a topic that should be addressed. And so I'll put this question out for the group. How can Alaskans ensure the safety of our food supplies, both what's gathered from the land, like berries or moose, and from the ocean, with this anticipated future of potentially more nuclear power in Alaska?
David, safety is always such an important issue to address. And I think, we are lucky to have the NRC. They are the best in the world at nuclear safety. They're real sticklers, and that's a good thing in this case. And so, I think having that really, really strong regulator is essential in maintaining safety at the local level with any facility. And, a lot of these smaller reactors have inherent safety features that are really modern and really cool and meant to even further mitigate the risk of any type of environmental contamination. So I think those are important questions, and they're also worth digging into more deeply. The ins and outs of some of this stuff is really, really important. What technologies you consider, the size and scale of the reactor, all of these are critical questions, I think, as you consider nuclear in Alaska. But I will say our safety record is pretty solid, and in large part due to the regulatory environment here in the US.
Thank you, Susie. And I guess I would add to that response that the reality we're living with is that there are contaminated sites all over the state that are not nuclear. In fact, I noticed that the Eielson military base, where the SMR is going in by 2027, there are prohibitions on that Army base for fishing because of prior contamination both diesel range organics and PFAS. So it's not as if there's an alternative that has zero risk. I think the alternatives, and Gwen makes this point very well, that the current system in rural Alaska, particularly of relying on diesel fuel for power generation, comes with environmental impacts. Let's see, Andrew McDonald had a question. With the prospects for deploying reactors in Alaska, what steps have been taken so far to engage with the community and native groups in free, prior, and informed consent? I'd like to take a stab at answering that and then open it up to other input. I don't think we're at this point of informed consent because aside from the Eielson project, there isn't a proposed project currently. There was the Galena nuclear power plant project that was proposed in, I believe, 2006. It was for a 10 megawatt project in the village of Galena on the Yukon River. And there's quite a bit online available about that. But there was strong engagement with the community on that. The one thing I would add is that Gwen and I have actually been involved in organizing the Rural Energy Conference for most of the past 20 years. We've collaborated on that. And I think our first nuclear power workshop was in 2006 or 7. And then the Forum on the Environment has also addressed this project numerous times. I mean, the concepts of nuclear power in Alaska. So there's been information provided and shared, but not to the point of informed consent, aside from Galena. And I actually don't know the details on Galena. If there's somebody listening who does know, have a better answer for that, please speak up or put it in the chat. Okay, so Gwen posted a question. She says, I'm interested in this question of recycling fuel. My understanding that TRISO will be almost impossible to recycle for the exact reason it is inherently safe. Breaking apart those little poppy seeds is difficult. I understand some recycled fuels will be used for early batches of fuel for MNRs, but I didn't think recycling was the general plan for longer term fuel production. So with recycling, to what extent are we talking about recycling fuels from legacy reactors? And how is this different from HALEU versus TRISO?
When I'm out of my depth here.
Okay.
I am not a recycling expert.
And then there's a response from John Hansen. I'm not an expert on TRISO and will defer to TRISO folks for their input. Oklo is designing metal-fueled reactors, and metal fuel is readily recyclable. The recycled fuel that we would produce in this way would be a replacement for fresh HALEU, and our reactors are designed to run on both recycled and fresh fuel. We can also recycle existing used oxide fuel with the same process. Okay, well, I welcome other questions related to our topic of environmentally and socially responsible. I think we've already come up with a list of good questions for Alaskans to consider in the future. But without further questions turning up in the chat, I'm happy to turn it over to George to continue at this point.
Thanks a lot, David. And thanks a lot, Rob and Susie. I have a couple questions in this particular topic area, though, that I would love to hear both of you address. Initially, Rob, early in your remarks, you read from a letter that was sent out. Was that related to the new project that's being considered by Energy Northwest to put an SMR in? And if so, where are we at in that basic process? And, is as peers, nation to nation, how are the tribes able to buy in or hold the phone kind of stuff?
Well, This letter was written in August 6th, 2021 to Brian Vance up at Hanford Site Manager. And we just got a reply from Dr. Huff, I believe, that was dated on the 15th. I haven't been able to read it yet. This letter was of course sent to the Richland field office, and the tribes don't want to see any more. I'll read you some of these. The natural resource management to Hanford and Hanford affected lands and resources should not be further developed, and no new nuclear missions or expansion of nuclear energy, nor new or expanded nuclear fuel storage undertaken. That's all. Wanting to maintain the footprint as it stands now. Cleanup operations. They want to reuse of existing uncontaminated facilities is tolerable within current development footprints. No long as no expansion of the footprint occurs, no additional natural resources are taken, and no hazardous radioactive waste generated. So I don't know if this answers your question or not.
That's super helpful. And is that from the Umatilla, or is it from all of the tribes in the area?
No, this is
consensus.
Confederated Tribes of the Umatilla Indian Reservation.
Okay.
So we were asked to comment on the proposed SMR.
Mm-hmm.
And this is the response that we came up with.
Interesting. Susie, one of the things that I wanted to ask you was, I actually met you at one of these nuclear futures things that University of Michigan coordinated. My understanding is that these are periodic outreach things, bring in people from diverse backgrounds, perspectives, etc. And I asked in the chat, what do you think about doing such a thing in Alaska? You said, count me in. Okay, this is permanent record, right?
I would love to come back to Alaska, George.
But help us understand, how does one of these workshops go, and what's the purpose, and how do you see this as being maybe a model for having constructive dialogue about difficult subjects?
Sure. Yeah. So this series is really the brainchild of my longtime mentor, Dr. Todd Allen. And he has organized these around all kinds of different topic areas where we, as a community, need to sort of dig in and do some learning. And so I can connect you with him to have a conversation about that. I think it's a great idea. I also wanted to circle back to the letter. In advance of this meeting, Rob, I reached out to our tribal affairs liaison to get an update on that process. And my understanding is they are in the process of, in the letter, there was a request for a formal government-to-government consultation about that issue. And they are in the process of setting that up now. And that was the response from Dr. Huff, was absolutely, let's sit down and talk about this. So just for the record, for you and for George to know that we are working on that and want to come to the table and talk more.
Thanks a lot, Susie. And Susie, I'm just going to pick on you one more time here, because I know that you want to be careful that you don't overstate what you know and things like this, but you know a lot. And so one of the things that I'm really interested in is, like, as you've been reaching out and, you develop different tools, you've been in different venues, different organizations. What are some of the ways that you think Alaskans should be considering in terms of making sure that we're getting these environmental and social topic areas out in front of us, and hearing people, having people listen to each other, et cetera?
And George, I think that y'all are really on track, right? Like, there are a bunch of folks within the state who are driving this conversation. It's not that there are outsiders coming in and telling you what to do. And I think that dynamic is really healthy and really admirable. But, the leadership is coming from within. So I wish I had advice, but I actually think you're sort of a model state among the many sort of scenarios that I've witnessed, in that y'all are really driving the conversation. I think that's appropriate.
It's encouraging to hear. Rob, in terms of when you and I talked a little bit earlier this morning, it was interesting listening about there's no language word for radiation, and interesting using the word angry or anger to kind of reflect the functional. And what I wondered is, when you look at the youth in your area, or you look at people that are maybe young parents, or people that are in the workforce or coming into the workforce, how would a reactor, or the business around a reactor, in terms of like a hydrogen plant or this or that, are those kinds of things generally interesting? As like, I want to be part of that. I mean, how do people interact with that where you live?
It's not really known. I mean, folks know the Hanford's up there and what it represents and what it does, but there's no real interest in it. Folks plug in their phone to charge it and things like that, and that's as far as their interest goes. The fire department has been trying to get some more interest going as far as the STEM program, and trying to get the tribal kids to get more interested in the sciences. And that we think will help turn the corner as far as getting folks educated and understanding nuclear power. I'm comfortable with nuclear power and stuff like that because of my background, but the other folks are, it's not really in their interest. But until we get the kids understanding and into the sciences, then I think we'll, like I said, turn the corner and get the older folks involved, going from younger to older instead of older to younger.
That's really interesting. I mean, I am really not into brainwashing, but I am definitely into facts and knowledge, sharing truth and getting people to interact with concepts and learning vernacular, et cetera. And I know that, Susie, your department actually has a fairly active STEM program. I think Michelle Higgins maybe is the name of the person that is leading that up.
Melinda Higgins, yes.
Melinda Higgins, that's it, yeah.
Yeah.
And so, Rob, if there is at some point an interest in like your reservation working with those kind of materials, that would be something that we can definitely get some of your teachers involved with Michelle and coordinated with that awareness. I guess the last thing that I just wanted to chat here before we go over to our final panel here. So Gwen asks, let's see. Gwen asks if there are some best practices for communicating complex information with tribes and communities. And I think she points out that misinformation is dangerous, misunderstanding is dangerous, and it's not just about nuclear, it's just in general. And you tend to trust the people that tell you something, and then you internalize that and perhaps don't look beyond the first articulation. And so are there any best practices from either of your experiences? Like, Rob, in your world as a first responder in the fire world, et cetera, like, I'm guessing that at some point, your department, if hydrogen cars become a reality, widespread, it's going to require some training. And you're already doing training, I'm sure, on how do you respond to an electric vehicle car fire or a crash so that you're safe. It would be interesting to understand how you go about familiarizing yourselves and the people around you with how should you act with this? This is different. Here's the facts about this. And then Susie, in terms of your own work, looking at, it's hard to unwind something, once it's out there and has kind of legs and momentum. But are there things that you've seen that would be helpful for us to, not argue, but provide constructive ways of offering here's some other things to think about, or here's another person that you might want to visit with. I'm just curious from either one of you in your different roles.
Well, training really helps, not just the fire department and the responders, but it also helps the community. Our fire station situated in kind of in central of our housing projects or housing on the reservation, and they see us out there every Monday training. And well, what are you guys doing today? Well, we're practicing on ladders, or we're practicing on that. But the thing that really gets them kind of excited is when we're recertifying our not dose meters, but our meters and stuff like that, or our hazardous materials equipment. And they'll come by and say, hey, what are you guys doing? And we'll explain it to them. And when we'll have the old lantern mantles that have just a low level of radiation that picks up on meters, we'll show them that stuff for some of the old ceramic dishes, and that really gets people excited, and so they kind of understand it's something not to be that afraid of. That makes sense, but it's kind of an education for the folks that stop by and ask.
Susie, any thoughts?
Yeah, I mean, to Rob's earlier comment about how do we get this into schools? I think where possible, integrating this into STEM education is really important, because it isn't sort of it's just basic science education in a lot of ways that folks need access to. But then, in places where we have histories and conflicts and legacy issues where we are trying to understand a path forward, those are situations that get a lot trickier. And, I don't have easy answers on this one. I mean, I think really just showing up and listening and taking people really seriously, and no meaning no, some really basic sort of just good manners. I'm from Georgia, just treat people with respect and use your manners. And that goes a long way. But, there are many, many communities in the US and globally that would love these technologies. And so I think it's sort of my feeling that there's no reason to push these technologies where they're unwanted. And to remember that we have made mistakes, and that some of this distrust has been earned in that mistake-making process. And so, sorry, George, those aren't great answers, but that's the best I've got.
Thank you. I love both of your inputs. I love it when questions or responses come in directions that oh my gosh, I didn't even think about that facet. So that's great. I guess, David, if you would come back on camera, I wanted to just ask you, as you were preparing your thoughts for this particular panel, and I know these are questions that you hold very deeply in terms of this, is it environmentally responsible? Is it socially responsible, et cetera? As we've kind of heard interaction around this, one of the things, we're both engineers, and so engineers love data, right? And so one of the things that I wonder is, what kind of data do you think we need to help us answer these kinds of questions?
That's a great question. And I think for myself and maybe for others, with nuclear power, there's a temptation to go to an extreme immediately, to say either, yes, this is the right solution for everything, or no, this is never a solution and we shouldn't even talk about it. And but your question is more appropriate. And not only do I think we need data, we need time. So one of the things that you and Gwen and I have been working with others on, particularly Ashley Finan at the Nuclear Reactor Innovation Center at INL, is the idea of developing a roadmap for nuclear power development in Alaska. And that roadmap is not a guarantee to end up with widespread nuclear power in Alaska. It's a process of gathering information and proceeding in a responsible way to look at this technology to see if it's appropriate for some of the uses that we've talked about. And Gwen and I have been talking, I mean, we keep talking about how many years, but it's a very long time, 10 years or more, about the idea that a military base is the place to start. Well, lo and behold, look, we're going to have a nuclear power plant at a nuclear base in Alaska. And I'm not claiming to take responsibility for that, but I'm thrilled that that is going to be a step forward in responding to what you've just asked. We need information. We need information about how these projects work, what they cost, what the safety measures required are, how we can do them successfully, build these projects successfully in Alaska. And we're going to learn something, I believe. Just like I am a strong advocate for looking at the history of nuclear power in Alaska and not trying to overlook any of that information, which should also inform our decisions. So long answer, but just to sum it up, I think we need small modular nuclear projects at a military base, maybe at a mining site, in communities that will welcome it. I think we need to look at the potential on the rail belt even. There was talk earlier about how cheap the natural gas is. Well, it's actually not so cheap right now. And the future of the cost of natural gas is uncertain and probably increasing cost. So the potential for heat as well as power from these devices is very intriguing. And there are, UAF has the most recent coal-fired power plant in the country, and it was built probably to a large extent because it heats the campus. And so that kind of opportunity to develop small combined heat and power projects is really, really attractive in Alaska. And that's a direction I think we should go, is to talk about. I just read Gwen's comment. That's the direction we need to go, is to gather data about the potential for Alaska-specific applications of this technology. And I'm really excited about the roadmap concept.
Thank you. We're going to close this particular panel in just a moment, but I wanted to share just one thought. I can't remember if it's Inupiat or Yupik, but there's a word, it's spelled Suivsi in English, and it's pronounced Suivsi, I believe, and it means, what are the many people doing? And this is something that I think is really important for us to be doing as we're looking into this dream for a future that is sustainable, that reduces, potentially eliminates carbon content wherever possible, to not go it alone, and to try to find ways to work with one another. I think we all have different rings that intersect in different ways. And so, like, Rob, I just love the fact that you're, shoulder to shoulder with so many other Native American tribal communities that are involved with nuclear through NetWig. Susie, I appreciated you sharing that. But I think that's like an example of how people who have deep love for the land and who have an understanding of thinking way down the road. How can we bring that kind of mindset into broader communities, and how can people work together, tribes work together? And I think that, like, looking at, in many ways, we steward our areas of influence and our opportunities. Like, how can Eielson steward this opportunity on behalf of Alaska to explore how does a microreactor work in the North? We should all be like, hello, I'm interested. Here's my questions, and shaping that, and then working with NRIC. So there's all these different intersections that we all have. And I think that's part of what makes it environmentally and socially responsible. Understanding this by bringing in people who think through different lenses, who have different data, et cetera. So as our two folks that have joined us on this particular panel to help us explore this, this is one of those things where engineers hate things where there aren't black and white answers, right? Because, like, where's the fulcrum? I just put a lever on this. These are difficult. And we need to think through these things and make decisions based on what's important to the people that these tools are going to serve. So thank you. Again, David, thank you so much for your moderating work. And I think we're going to move now into the final portion of our program. And we're going to ask the moderators from the 4 panels to join us. I see Christy coming online. David, I'm guessing, is going to join us here in just a moment. Let's see. Do we have our other moderators joining us here? I might. Very good. 4 for 4. So this is one of those things, like, have you been to like a fireside chat and you show up there and you realize, I'm not sure these people have actually been in the same room before they were on the stage. Good news, you were all in the same meeting for 2 days, listening to one another's work. You know each other. And so I would love to hear, as you have heard each other's panels, as you reflected on what happened during your own particular panels, are there any meta narratives that stand out to you?
There's a huge opportunity for Alaska. We've started some really great questions. And now I think it's an opportunity for us all to, continue to reflect on those questions, continue to ask additional questions, and figure out whether there's an opportunity for us as a state. And again, I speak as an economic development practitioner, but it just seems, I love the idea of the manufacturing component. I really love this last discussion about how we really engage more voices into this to really figure out what's best for Alaska. What do we want? What's our definition of success for our future? And how do we perhaps use this technology as part of that?
It was interesting to see that opportunity was one of those words that showed up in the word cloud. So it's clearly you're onto a resonant frequency there. Others of you?
I'll go ahead and jump in. I think listening to the panel that I was on and then multiple panels is, I think one of the things we have to be really careful of is projecting over what timelines these things are actually going to happen. It really crystallized to me for the last one when you compare what Alice and Christine showed about over what time period these demonstration projects and technologies are going to be developed and licensed. There's a big difference between opening up, whether it's the NRC process or some other process, to look at technologies. That's a long way before actually turning dirt and putting something out there where I think communities can feel threatened or that something is put upon them. And I think I like to consider myself a pretty well-informed Alaskan when it comes to process. After 20-something years in the political world, I can't describe the depths of the NRC process, how that works for public engagement, what opportunities for consultation there are, with tribal governments. All of those things are things that I think it's incumbent on everybody looking at this industry to do a bit better, laying out that roadmap in context of the technology. And I say that because Alaskans are pretty used to NEPA and various stakeholder engagement processes. They're very sophisticated compared to stakeholders in other states. And I just think we can do more to educate on that process to get to the opportunity.
David or Lou, any big things that jumped out at you from your own panels or from listening to the others?
George, I'll offer a perspective from the Is It Safe panel. So we had Bruce come on and provide a lot of objective analysis data that said that there's a track history in the nuclear energy business of safety. And then he talked about how that's going to be improved in the future with the inherently safe models that they're developing in the microreactor space. And then Mo came on after that and asserted that the NRC is a fiercely independent and effective regulator and talked about the track record that they had to support that. But I think I would say, thinking more broadly, that that's not enough. I think the last panel really is where the issue lies. It's not enough for the technical folks to come forward and say, we guarantee that you will have no more than 1.5 events per 10 to the 7th reactor years. It just doesn't help, right? No one's going to look at that and say, I'm much more comfortable now having a microreactor 30 yards away from my house. It just won't do it. The question of ultimate life cycle management, what to do with the spent fuel. People just aren't comfortable yet. And I think that we have to acknowledge that and understand it and continue to do our very, very best to come up with solutions that'll really work. And so I think that the social aspect of this is really the key. And that's got to be, I think, the most important part of the roadmap. The NRC will figure out how to license these things, right? They've got lots of smart people in that building back in Maryland. And the developers will figure out how to develop them, and they'll figure out how to put them on barges and airplanes. All this stuff will work. But I think at the end of the day, people are going to ask the question, why should I use this technology when there are other well-developed, established, low to zero carbon technologies that can provide my needs for energy? Why this one? Why can't we just put this one away? But I think it's a vital question because nuclear energy represents a unique solution, particularly for a lot of the use cases here in Alaska. And so I if I was going to stop doing anything and prioritize on one thing, it would be to focus on the roadmap and engaging the people who are going to be the ultimate users of this technology. And that's not an assured path. At the end of the day, they might say no. Right? We're not a command economy. And so I think it has to be approached on that basis. That they'll get to have a choice, but the best we can do is inform them with the facts.
Just to be clear, could you explain the term command economy?
Oh, we don't tell people what they can do. At the end of the day, they have a choice.
Got it. Thank you.
Private companies make investment decisions, but still, any kind of permitting would have a local component.
Yeah.
Well, maybe that question about a command economy is a good lead into my contribution. But I want to make sure you were finished, Lou.
Yes.
Okay. So over the weekend, I watched the miniseries Chernobyl. And I would recommend it, not because I think it represents the future of nuclear power, but there were a number of interesting takeaways, and it was done very well. But the thing that intrigued me the most is that President Gorbachev attributed the impact of Chernobyl to the end of the Soviet Union. That I had no idea about, and I thought that was really significant. And then look where we are today. Russian troops lined up outside of Ukraine. And by the way, I'm not trying to make a political point. And now I suspect people in France and Germany particularly, are thinking carefully about their future nuclear policy in Germany related to these conflicts and issues around Ukraine and Russia. Not making a political point. My point is energy is amazingly important. And there is no source of energy that doesn't have potential problems. And in some ways, it's not so much which source you use, it's how carefully you do it. So to the extent we're going to have a variety of types of nuclear power in the future of our country and possibly our state, well, I guess there's a certainty in our state, we need to do it really carefully. And that was one of my major takeaways. And actually, Rob's involvement was intriguing to me. I spend all my time thinking about Alaska, so I don't think much about the Pacific Northwest. And they're very different from us in many ways. They have some of the cheapest electricity in the country and really large hydro. Well, they have problems with their hydro, right? Salmon. And I don't know much about it, except I've read about it for every time I hear any reference to it, to the Columbia River, I hear about the problems with the salmon. So I think my conclusion is that all kinds of energy resources bring problems with them. And what's really important is to make careful decisions and then proceed with caution and really good engineering and good management. Thank you.
Thank you, David. You had your hand up earlier. Did you have a comment?
Yeah, I did a little bit. One of the other takeaways I had in thinking about the way the system works kind of builds off Lou's point about command economy and what David said about every energy source having its challenges. I think there's a lot of focus trying to understand what these cost. And I guess I come at it from a different perspective and think about it more of, number one, what are the utilities willing to pay? Because these are going to go through power purchase agreements, by and large, that are going to be negotiated by local utilities and overseen in many instances by the Regulatory Commission of Alaska. So in thinking about, is it economic and does it fit into our system? And how does it balance against the other potential energy sources out there? There are different processes in checks and balances in the system that is another area that we may want to look at as a state. But ultimately, I think people should recognize some of those are in place. And the investment or development costs and the purchase price of energy are really the challenge of the utility and the private developers who are going to be standing behind these projects. So I just throw that out there as people need to think about the way these work in an actual utility context.
Mm-hmm. Let me ask all of you a question that's time-based. I can't remember which of you brought up the idea of timeline, but we're looking at commercial reactors not being available until some people say as soon as 5 years, so other people say 7, other people say beyond. And those are like first of model commercial reactors. A lot is going to change in 5 or 7 or more years. And one of the things that I wonder is, what is our time window from your different vantage points, what you've heard in your teams, what you've heard from one another, in terms of developing this sense of we want to go in the following direction, and for our state, for our people, this is what we value, and these are the resources that we need to get us there. Like we need not the solution set, but like we need this kind of heat capability. Do we want it distributed? Do we need it central? We need this kind of transportation capability. We need this kind of shelter. We need this kind of power to do these things that we care about. These are the things we care about. That's a pull, right? That's not anybody pushing. And I'm wondering, what do you see as the pulls and what do you see the timeline? And then I warn you that I'm going to use the S word after this, and I'm going to let you know in a moment what the S word is. So go ahead and tell me what you think about how do we get to understand, clarifying what's important to us from a poll perspective, and how do we understand the basic time we have for developing that.
So I'll address the timeline and then let these smarter gentlemen jump in on more of the technology components. But the timeline itself, and I don't know, I'm certain many of us mentioned it, but I mentioned, economic development happens in 20-year windows and it resets every day. And when I was, jumping into the field of economic development as a 20-something, and people told me that, I was like, yeah, that's just because people aren't rolling up their sleeves and getting stuff done, and let's get it done. And what I've learned is economic development happens in 20-year buckets. A planning process takes a year to 2 years. Then the commitment process, once you finally get a community bought in, the financial component to put something together can take another year or two. Technologies change during that, and so choices may change. And so you're having these ongoing conversations. And then once you start trying to build something, that can be, particularly in Alaska, another 2-year cycle. And so, just something as simple as an uplands development in a coastal community, I've watched that process take 10 years. And that's with like really known variables. So when we talk about something like micronuclear, where there's, the technology isn't fully there, there's history that we have to grapple with. And I loved Mr. Burnside's comments about we have to both engage the youth, and this is my interpretation, so I'm sorry if I'm reinterpreting it wrong, but we need to engage both the elders and the youth, because the decisions we're making today are impacting our kids. And they have to be bought in on that solution just as much as the elders, because we're talking 10, 20 years down the road. So there's all these really diverse components that we have to weave in here. And it's way greater than just do we do this or do we not do this? On the flip side, I do think, I'll get back to that opportunity word. I can't wait to hear the S word. Just to prepare ourselves for the manufacturing, just to prepare ourselves for, I love the topic because it's a space that I really want Alaska to merge more in, is, this I'm not even going to get the word right now, but a more mature manufacturing society here in Alaska, advanced manufacturing. There's a lot just for us to prepare in that space, both on, preparing the workforce, let alone preparing the business community. So I'll stop.
Can I say wow? And let's listen to the others here. How do we get to pull? What is the time constant? So Christy lays out 20-year blocks, very long time, even with known quantities in terms of technology or tools.
George, I actually think we're doing it. And, leadership from people like you, Christy and Gwen and the others involved in this effort. We've got a lot of very experienced and intelligent, thoughtful people who care about the future of Alaska participating in this effort. And there's more to come, and it's coming quickly. I'm almost overwhelmed with all of the interest and energy going into the future of energy. So I think the pull is we're absolutely driven by climate change. Alaska is the canary in the coal mine. If you're not from Alaska, you may not have heard that, but that's what we say. And we're being impacted all over the place. I spent most of my years, my career here building bulk fuel tank farms in villages. And I'm proud of that because the ones we replaced were leaking, but that's not the future, the long-term future for most of Alaska, I think. So we need this kind of a planning effort. And as Christy said, a vision, a long-term vision for the future and start working on it now.
Fish or Lou,
George,
go ahead.
I'm not sure when. I think David's right about what creates the pull. But the question is when. And so I think that's much less predictable. But I think there's an urgency now to move forward on both the development front, this opportunity that the Air Force is offering at Alaskan is very important because they've decided to go through the commercial siting process, right? They're gonna go through an NRC licensing process. So the many hurdles that have to be overcome to get to that point, we're gonna go over all those hurdles. We're gonna actually learn what it takes to site, install, and operate a micro reactor in Alaska. So that's very important. None of these other things we've talked about are going to happen unless that's capable of occurring. And in parallel, there has to be the whole broader education and really conversation about whether or not this is a technology that people want to use. So I don't know when the strong pull will occur, but I think we have to do everything that we can right away to prepare so that when it does happen, that we have a feasible technological option to offer people.
So in the chat, Paul Ropey and others point out this aspect of climate change that's driving the need to address the issues. In many cases, the ocean's not going to wait around until we figure out what we want to do. It's going to wash away XYZ communities. And we don't have time to figure out what to do or in terms of a future technology. We need to do something now. And this is where the S word comes in. So for me, the S word is synergy. So I am looking for opportunities, challenges that we must address. And how can we address those in ways that don't commit us to only one particular course of action, but leave us opportunities for bringing in alternative things like how can we learn enough about hydrogen as a storage medium as applied with variable renewables, as applied with nuclear that benefits from a high capacity factor load, et cetera. What are the issues we need to look at there that aren't unique to nuclear or wind or whatever, but they're shared, there's synergy there. And when we develop opportunities for looking at putting a new power plant, if we're going to put a new power plant in, for example, with the Newtok relocation, putting in the heat recovery system, looking at a heating district, how do we capture that stuff we have to do anyway as learning opportunities, just like we talked about the Alaskan experience as a pathfinder for so many different things? How do we take advantage of, Churchill said, never waste a good crisis. You know, we got a crisis on our hand. And I remember one of the engineers in my team when I was at Boeing, helping me understand the kanji for the express crisis in Chinese. It's two words. One is danger and one is opportunity. And to me, that's synergy. You must avoid danger. It's desirable to pursue opportunity. How do you do this together? And so I think this is the big context that we're in right now. There's so many different assets that we can leverage. There's so many different challenges we have to face. We have to make some quick decisions, and we have some long decisions. So I just think this is a process that's going to require careful thought and many voices, many perspectives. And I think it's a marathon, not a sprint. I'm going to stop using platitudes, but these are, I think it's just, I'm just so excited that we're working together here, and we have so many people that are able to help us understand and learn and just complement what we know in our situation. So good. So I'm going to reach out to Gwen here, because I think she's got some wrap up remarks. I want to thank all of you for being here with us and sharing your kind of boiling up kind of insights. And Gwen, I would love to hear your own observations and how you're going to commission us to move into the future.
No, it's been really great, and I really appreciate, some of the comments that, especially Alaskans have been, really driving this conversation. And I feel like we've had a lot of really fantastic folks that have been working to pull this together and other events. And like I mentioned, there's going to be plenty of opportunity for continued engagement. For those of you that have stuck around to the end of this, I hope that you are already participating in the Alaska Nuclear Working Group. If you're not, please sign up for that. That would be the best way probably for continued engagement. We're really hoping to synthesize a lot of the feedback that we've got here. The chat's been super active, and there's so many great questions and thoughts that have been put in here. And so I really appreciate everyone's time. There have been fantastic conversations. Especially I appreciate the moderators for really putting in a little bit above and beyond the extra effort for working with their panelists and really making sure that we have some really honest conversations here. So anyhow, I think we have a slide up just on here you go, the Nuclear Energy Working Group. So these are monthly meetings, and please reach out to us. I should also mention, we are going to be having these other workshops, including the hydrogen one. We're thinking pretty seriously about forming a hydrogen working group for the state of Alaska under sort of a similar kind of model. So if that's something that you might be interested in too, reach out to us at the Alaska Center for Energy and Power. And that might be something that's kind of coming up here in the next couple of months. And so, as I mentioned before, the recording of this workshop is going to be available on the Alaska Sustainable Energy Conference site, along with the slides. I know I will be certainly interested in taking another look at a few of those. So that's going to probably be in about a week or so. I'm actually hoping that we can send out a email to all of the participants. I haven't actually checked that with Martha and her team, but I'm hoping we can just send one out to everyone that signed up to let them know when that does become available. And we're also going to send out a short survey. We would really appreciate it if you provide feedback. I'm actually hoping, even though we're talking about there being these 4 workshops, my intention is actually to kind of continue to have these sorts of workshops on a monthly or a quarterly basis, hosted by the Alaska Center for Energy and Power, because this is kind of where, as a research group, I feel like we can really dig down into the details of a technology area a little bit with kind of quite a bit more depth. And so if you guys could fill out that survey, that would really help us in terms of thinking about whether this is something we want to continue to do, and if so, what kinds of topics we might want to explore, and how we can kind of improve this process. So the next workshop is going to be called Going with the Flow. Wait, that's not true, actually. That is not accurate. It's actually going to be the hydrokinetic one, ocean and river energy one, which will be on the 1st and 2nd of March. And then we'll go into the hydrogen one after that. Hopefully that is accurate. Uh-oh. Okay. We are clearly not clear on what the next workshop is, but I'm pretty sure it's the Ocean and River Energy one. We'll just have to check that. So anyway, and then the Arctic X event, Innovation X Lab event, doing business with Dewey and Arctic is happening on April 6th. So we'll have some information on that as well. And that is something that George Rowe and the Arctic Energy office are leading. So please visit their website at energy.gov Arctic X to register for more information. And of course, we definitely hope to see you at the Alaska Sustainable Energy Conference in May. I've gotten a couple of confirmations from folks that have been speakers here and presenters that they'll be coming to that conference. And so we hope we can continue this dialogue around nuclear energy at that event. So hope to see you all there. And thank you so much for your time and interest in this topic. And we'll stay in touch. So thank you.